2q divided by r squared. There we go. And let's see now, C less than R less than D. So now we're in this outer region, okay? So if we're in this outer region, I know that electric field must be equal to 0 here in this region, because when we're in a conductor, the net electric field must be 0. I have plus 2q here, so I need minus 2q on this inner surface. But in general, E still must be equal to 0 there, because we are inside of a conductor. And finally, when we are outside of this system, all you have to do is take the total charge minus 4q plus 2q is minus 2q. So q enclosed is minus 2q. And we get E equals 1 divided by 4 pi epsilon times minus 2q over r squared. All right, we can go ahead and graph this. And what do we see? 0, 0. So this is 0 here, 0 there. Between B and C, we see 2 over 4 pi epsilon 0 r squared, so something like this. And now we have to remember one of the properties. So even though that this is a quadratic function, you can get out your graphing calculator and see what happens when you have a negative value outside of your expression that you're working with. So I'm graphing it now, and I think that all of you should graph it as well to see what happens when you have a negative sign outside of the expression. So it looks like we do something like this. Or more, oh, excuse me. When you graph it, there will be two solutions. Make sure that you choose the physical solution. And so in this instance, it will be something like this. All right, there we go. Okay, so now we can look at the charges that are around these shells. Okay, let's look at the inner surface of our small. The inner surface of our small, remember, electric field must be 0. There's nothing on the very, very inside of this guy where that green dot is. So this guy must be 0. What about on the outer surface? Outer surface must be the total charge on this shell, plus 2q. Okay, let's look at the large one. Okay, on the inner surface, we need to have an electric field of 0, so it has to cancel the total charge from this inner shell. So we need a negative 2q on that inner surface. Okay, and then what about on the outer surface? Well, on the outer surface, all that you have to do is think about, okay, well, there's minus 2q right here. What has to be out there? Minus 2q. That's the only way for the net charge to be like this. So it has to be minus 2q. There we go. Q. There we go.
Welcome to EDU World Space.
Okay, so we have two concentric spherical shells in a radius A, outer radius B of our inner shell, and a radius C, outer radius C of their outer shell. The inner shell has a total charge
Welcome
of
to
plus
EDU
2q.
World
The outer
Space.
shell has a total charge of minus 2q, and we're going to
Okay,
find the electric
so
field
we
everywhere
have
and
two concentric
where the
spherical,
charges are located.
so let's get started.
Shells in a radius A,
So
outer radius B of our
remember
inner shell,
that
and a
when
radius
you
C,
have a
outer
point
radius C of their
charge,
outer shell.
the electric field
The inner
is
shell
given by
has a
this.
Welcome to
Remember,
EDU
what
World
the outer
Space.
shell has a
K
total charge of minus 2q, and we're
equals
going to find the
9.
electric
So
field
we
everywhere
have times
and
10 to the
where
9.
the charges are located.
It's also
Let's get
equal
shells in a
to
radius
1
A,
over
outer
pi
radius B of
remember
our inner shell,
that
and a
when
radius
you
C,
have a
outer
point
radius C of
charge,
their outer shell.
the electric field
The inner
is
shell
given by
has
this.
Welcome to
Remember,
EDU World
also
Space.
remember
the
Gauss
total
law.
charge of minus
Here it is.
2q, and we're
Equals
going to find the
9.
electric
So
field
we
everywhere
have times
and
10 to the
where
9.
the charges are
Says that the
located.
closed is also
Let's get
equal to the
shells
integral of E dot
in a
to 1
radius
over
A,
so
the
pi
total
has
field
closed
divided by
epsilon.
that
And
in a
when
radius
you
C,
have a
outer
point
radius C of
charge,
their
so
outer shell.
the
First
electric
region,
field
the inner
is
shell
given
has
by
less
this.
Welcome to
Remember,
EDU World
also
Space.
remember
has a
Gauss
total
law.
charge of minus
Here it is.
2q.
We are over
Okay,
9
so
is the little
we
green
have
dot times 10 to the 9
there with no
says that the
charge.
closed is also
Let's
equal
get
to the
shells.
integral of E
So
dot
E
to 1
Alrighty,
over
so
pi
remember
has
the
closed
divided by
unknowns
that
are
in a
Okay,
radius
have
C,
a
outer
point
radius C of
charge.
their
Alright,
outer
so
shell.
the
Gamma,
electric field
The inner
is
shell
given
has
by
less
this.
Welcome to
Remember,
EDU
F,
World
also
Space.
remember
Okay,
Gauss
this
law.
is
F
A.
Here it is. We are
and
over
F
9
sub
is the
one.
little green dot
Is that
times
and
10 to the
zero
9
there with no
says that the
charge.
closed also equal to the
So we
integral
do
of
have
E dot
enough
to 1
already.
over
So
pi has
The
closed.
unknowns are
Okay, have a
alpha,
point charge. So the
gamma,
electric field
sub
is given by this.
Welcome to
from
EDU
F
World
Also
Space.
remember
equals
Gauss
F
law.
sub
Here it
X
is. We are over
F
9
sub
is the little green
Y. I
dot
can see.
times 10 to the 9 says that the closed also equal to
So
the
we
integral
do
of
have
E dot
enough
to 1
already. Put
over
those
pi
together and
has
see
closed.
the unknowns are
Okay, have a point
alpha,
charge. So
third
the electric
gamma,
field
sub
is
fourth
given by this.
equation.
Welcome
If I
to
put
EDU
all
World
those
Also
Space.
in
remember
here,
Gauss
it's
law.
just
We
that
are over 9 is the little green dot
I don't want
times
that.
10 to the 9 says that the closed also equal to the
So we
integral
do
of
have
E dot
enough
to 1
already. Put
over
those
pi
together and
has
see
closed.
the unknowns are
1
alpha,
so
third
the electric
gamma,
field
sub
is
fourth
given by
equation.
this.
If I put all
Also
those in
remember
here,
Gauss
it's
law.
just
We
that.
are over 9 is the little green
I
dot
don't want that.
10 to the 9 says that the closed also equal to
So
the
we
integral
do
of
have
E dot
enough
to 1
already. Put those
over
together
pi
and
has
see
closed.
the unknowns are
1
alpha,
so
third
the electric
gamma,
field
sub
is
fourth
given by
equation.
this.
If I put all
Also
those in
remember
here,
Gauss
it's
law.
just
We
that.
are over 9 is the little green
Oh,
dot
no, that's that.
10 to the 9 says that the closed also equal to
So
the
we
integral
do
of
have
E dot
enough
to 1
already. Put those
over
together
pi
and
has
see
closed.
the unknowns are
1
alpha,
so
third
the electric
gamma,
field
sub
is
fourth
given by
equation.
this.
If I put all
Also
those in
remember
here,
Gauss
it's
law.
just
We
that.
are over 9 is the little green
Oh,
dot
no, that's that.
10 to the 9 says that the closed also equal to
So
the
we do
integral
have
of E dot
enough
to 1
already. Put those
over
together
pi
and
has
see
closed.
the unknowns are
1
alpha,
so
third
the electric
gamma,
field
sub
is
fourth
given by
equation.
this.
If I put all
Also
those in
remember
here,
Gauss
it's
law.
just
We
that. Oh, no, that's that.
10 to the 9 says that the closed also equal to
So
the
we do
integral
have
of
enough
E dot
already.
to
Put
1
those together and
over
see
pi
the
has
unknowns
closed.
are
1
alpha,
so
third
the electric
gamma,
field
sub
is
fourth
given by this.
equation. If I put all those
Also
in
remember
here,
Gauss
it's
law.
just
We
that. No, that's that.
10 to the 9 says that the closed also equal to
So
the
we do
integral
have
of
enough
E
already.
dot
Put
to
those
1
together and see the unknowns are alpha, third gamma, sub fourth equation. If I put all those in here, it's just no, that's that.
10 to the 9 says that the closed also equal to
So
the
we do
integral
have
of
enough
E
already. Put those
over
together
pi
and
has
see
closed.
the unknowns are
1
sub fourth equation. If I put all those in here, it's just no, that's that.
10 to the 9 says that the closed also equal to
So
the
we do
integral
have enough
of E
already.
dot
Put
to 1
those together and see the unknowns are sub fourth equation. If I put all those in here, it's no, that's that.
10 to the 9 says that the closed also equal to the
So we do
integral
have enough
of E
already.
dot
Put
to 1
those together and see the unknowns are sub fourth equation. If I put all those in here, it's no, that's that.
10 to the 9 says that the closed also equal to
So
the
we do
integral
have enough
of E
already.
dot
Put
to 1
those together and see the unknowns are .5 squared.
Okay, so for this problem,
Minus cosine squared.
see if we
5
can
squared.
okay, find
where cosine squared.
see if
5
we can
squared.
okay,
So
find,
why is this cosine squared.
and this is our area element. This is our total charge enclosed.
.5 squared. So why is this
zero, and this is our area element. This is our total charge enclosed.
.5 squared. So why is this
by definition,
complex questions and break
it
them
must
down
have
into
zero
simple
electric
step-by-step
field.
solutions.
Zero, and this is our area element. This is
.5 squared. So why is
by definition, the total charge on this shell, it must have zero electric field. Zero, and this is our thing. Field of
.5 squared. So why is
by definition, the total charge on this shell, it must have zero electric field. Zero, and this is our thing. Field
.5 squared. So why
by definition, the total charge on this shell, it must have zero electric field. Zero, and this is our
.5 squared. So why
by definition, the total charge on this shell, it must have zero electric field. Zero, and this is
.5 squared. So
zero,
to solve this problem. So we know impulse momentum
And
theorem
that's that.
is F delta T
Also, another thing to note
equals
about
change
a bit taller.
So we have minus P initial, which is our delta P.
And
is going to solve the 30 kilograms because we defined this as a 1 second interval. We know impulse momentum
And
theorem
that's that.
when write out is F this portion.
also, another thing
remember
to note
that
about
momentum by delta. Minus P initial, which all over the time. Going to solve the 30 kilograms because we defined this as a 1 second final impulse momentum negative 16 meters per second minus the initial velocity, which is a positive 16. Remember that meters per second. You get an average divided by delta. Minus P initial, which all over the time. Going to solve the 30 kilograms because we defined this as a 1 second final impulse momentum negative 9, 16 meters per second. Rocket that is minus, or a space probe, sorry, not a rocket. Space probe has a rocket attached to it that is traveling in outer space. This retro rocket initial velocity down the probe positive 16. Remember that. You get an average divided by delta. Minus P initial, which all over the time. Solve the 30 kilograms because we defined this as a 1 second final impulse momentum negative 0, 16 meters per second, 6 newtons. That is minus, or a space probe, sorry, not a rocket. Of 4. Space probe has a rocket attached to it. This is where the little trick is in this problem. You have to read in this retro rocket initial velocity down the retro positive. Remember that. Motion going forward is positive by delta. Negative P initial in a time over the time. Look at our 30 kilograms here. We define this as a 1 second final impulse momentum negative 0, 16 meters per second. That happens during. That is to change in momentum. Space probe, sorry, not a rocket. Of 4. Space probe has a rocket attached to it. This is where the little trick is in this problem. You have to read in final rocket initial velocity down the retro positive. Remember that. Motion going forward is positive by zero initial in a time over 10. Look at our 30 kilograms here. We define this as a 1 second final momentum negative 0, 16 meters per second. That happens during times 10 to the 72 momentum. Space probe, sorry, not a rocket. Meters of 4. Space probe has a rocket attached to it. This is where the little trick is in this problem. That all equals final rocket initial velocity down the retro positive. Remember that. Going forward is positive. 0 initial in a type of 10 look at our 35 define this as a 1 second final -0 6 times meters per second that happens during times 10 to the 7th to Momentase probe, sorry, not a meters per second. Space probe has a rocket now. This is where the little trick is, and that all equals final. You can initialize remember that. Going forward is zero initial in a type of 10 look at our 35 define this as a 1 second final -0 6 times meters per second that happens during times 10 to the 7th to Momentase probe, sorry, not a meters per second. Space probe has a rocket now. This is where the little trick is, and that all equals final. You can initialize remember that.
Find P total.
Going forward is zero initial in a type of 10 look at our 35 define this as a 1 second final -0 6 times meters per second that happens during times 10 to the 7th to Momentase probe, sorry, not a meters per second. Space probe has a rocket now. This is where the little trick is, and that all equals final. You can initialize.
It is 2
So for 2, we have mass of 1.5 kilograms,
51.
velocity
2.6.
of negative
You
1.9
have to draw the circle.
meters per second.
Remember that.
Tells us we're going to need to add these up in order to determine that.
Of this
So we're going to get
Going forward is zero initial in a type of 10 look at our 35 define this as a 1 second final -0 6 times meters per second that happens during times 10 to the 7th to Momentase probe, sorry, not meters per second. Space probe has a rocket now. This is where the little trick is, and that all equals final. You can initialize.
momentum. In
and the
beginning,
maximum
before
implant
that whole
distance
contraction
is
for
just
2, we have mass of
132
this
or
is going to
which is
also
5
give
100,
us velocity
6.6,
of
10
negative
and
1.
6.
So now that
Have
I
to
know
draw the
P1
circle. And now
per
for
second.
the
Remember that.
draw the big circle that cover
So now that we know
these
P1
Going forward is zero initial in a type of 10 look at our 35 second and final impulse of negative 0 past teams, the least time cycle that happens during times 10 to the 7 to chain probe, sorry, not meters. Of course, space probe has a rocket attached to it. This is where the real trick is that all results final the rocket
momentum.
And the maximum intensity system is just 130 meters for
Going to also give us, in case you guys want the velocity
6,
of
10, and
negative.
6.
So now that
Have to
I
draw
know
the circle and now for
Welcome to
the
EDU.
Remember that.
Welcome to the channel. Here we tax complex questions and break them down.
Going forward is zero and a all built in look at our 30 1 second and final negative 0 past teams, the least time cycle that happens during times 10 to the 7 to chain space probe, sorry, not meters. Of course, space probe has a rocket attached to it. This is where the real trick is that all results final the rocket
is and the maximum intensity is just 130 meters for I will call this point A6 and that's 6. I will draw the circle and now for
Welcome to EDU.
Remember that.
Welcome to the channel. Here we tax complex questions and break them down.
Going forward is zero and a all built in look at our 30 1 second and final negative 0 past teams, the least time cycle that happens during times 10 to the 7 to chain probe, sorry, not meters. Of course, space probe has a rocket attached to it. This is where the real trick is that all results final the rocket
the maximum intensity is just 85 meters I will call this point A6 this angle that's 6. I will draw the circle and now for
Welcome to EDU.
Remember that.
Welcome to the channel. Here we tax complex questions and break them down.
Going forward is zero and a all built in look at our 30 1 second and final negative 0 past teams, the least time cycle that happens during times 10 to the 7 to space probe, sorry, not meters. Of course, space probe has a rocket attached to it. This is where the real trick is that all results final the rocket
the maximum intensity is just 85 I will call this point A6 this angle that's 6. I will draw the circle and now for
Welcome to EDU.
Remember that.
Welcome to the channel.
the upper half of the circle. Now
Overall,
for
we'll get a total final velocity
Here we text complex questions and break them down.
Going forward,
her final velocity is negative because we know that she
116
needs to have
10
a negative
plus
velocity.
all built-in look at our 35 mathematics as a 1 second final.
So just air. Now air has a mass that's much lighter than a bullet.
Welcome to
So here we
EDU
are
World
again.
Space.
Probe has teams, meters times seconds, happens during times 7 to 9 momentous probe chart, meters of space probe has a rocket. This is where the real trick is. Now that all results final rocket initial.
Negative
on the
y
direction
is
equal to
550
into 10 raised to 1 negative 6, right?
to
And
5
the
times
shear
10
strain
to
is
the
equal to
negative 4 kilograms.
negative
Notice
650
this is
into 10
drastically
raised to
lower
1 negative 6,
than what she
right? And
what
strain
the
is
mathematical
acting in
level.
this direction is
So when you
0 to
actually
positive
look
is
at
in
this,
respect to
everything
the
else is in
direction, right?
alpha.
Now we are going to use the
Welcome to EDU
My
World
second
Space.
round of the drill probe.
Girl, everything else is going to
circle
stay the same. What we're able to do
theory,
is
right?
reuse this
So
Remember that
the upper half, right? So
So I'm just going to
we
rewrite
have
up this
OC that is
equation,
equal
but
to
with
the
here
average value of the strain,
Here we
right?
text complex questions and break them
And
down.
going forward,
by 2,
EA
right? And when you
divided
calculate
by
it, you get the
negative
expression for this
So the
for
mass then
radius
has to change
as well, right?
accordingly.
So we have under root
So the mass now
the
is
difference of
5
this
times 10 to the
strains
negative
divided
4
by 2
kilograms.
whole square plus
The
the
velocity is still
shear strain divided
720.
by 2 whole square. You have the values, you just need to plug them in, and you get that it's equal to 3.5.
Her final velocity
One.
is negative because we know that she
116
needs to have velocity. A negative
Two. into 10 raised to power negative
So
6.
notice here that when
Right,
she shoots a
now
blank,
what we need to
she's
do
going to
is
have
we need to
much
graph
smaller
the
recoil
circle.
than she would
Look at our 35 mathematics as a 1 second final.
So just air.
So now as you
Air
can see over
has,
here that this is
has a mass
the
that's much
point
lighter
A
than
at
a
Welcome to the
which
channel.
Welcome to
Here we
EDU
text
World
complex
Space.
questions and break them
Momentous probe chart, meters of space probe has a rocket.
Of course, I'll begin by
That all results final rocket initial.
calculate the help of the circle. Now for that I strain is equal to negative
by
6
X
and
Z,
so
there
we
are
have the values,
three
you just need to plug
forces.
them in, and negative 650 is equal to
F2
negative 6, right? And the other principal strain is OC plus R,
F3,
right? Again, you have
which
the
is
values, just plug them in
vertical.
and you get your calculation is 0 of your answer and you know right? You get that direction, right? Now we are
And
going to
F1 that is
right?
the
Now that we
length.
have the values of the principal strain, we need to find out
It's
the
convenient.
maximum, right?
Remember that
Right, so when we
Five.
shift this to
Alright.
that is equal to
So,
find out the value of
since
the
F1 is
maximum
in the
inclined shear
XZ
strain,
plane and it's
right?
shown
So
like
correct
this,
value of the strain
Here we
gamma
text
from
complex questions and break them
going forward, but
that is
I believe
equal
that's
to
what
negative
they're
1
showing
to
us.
negative 2.
Now,
negative
since
f.
the principal
Using
function, they have the
proportions
same
is
sign, right?
4
They have the
fifths
same sign.
of
Now
90.
is
So same sign
negative
means
5.
that
And
we
that's
can
in
divide it
newtons.
by we can directly have the expression for the maximum value
Of course I can do this in my
and
head,
you have to calculate that
but I don't
is
want to
the
make a
maximum
mistake. So
amount,
4
and
fifths.
you get that equal to
I
equal to
think I also don't want to
10 raised to
think
power
too hard.
negative 6.
72.
This concludes our solution.
Means, okay, F1y is going to be, no, not y, z is going to be 3 fifths of 90. In the positive direction. F
plus epsilon y
two
into sine square theta
Negative
x, because it's in
gamma
the
x
negative
now what
x
we need to do
direction
is that we need to
is
draw a
negative
circle.
150.
Now
Let's get,
substituting the value,
oh
we
wait,
get
F2 is
gamma
not in that
xy
direction. I was
plus to be
confusing myself.
5.7 into 10 raised to
And
power
our conclusion
Sorry about that. I was thinking about in the z
part
direction.
a1.
So now
Okay, F2. What are we given about
this
F2?
This we get
We are given
0.0652.
that its projection
Now we have
Welcome
to
to
the
Text
onto
Complex
the XY plane is this direction
pi by 64.
60 degrees.
This is where the root
So I like to write Z. There are 3 forces F2 in the XY plane
XY. So
is
this is
F2
this is
138.99
times the cosine
plus 2
of
other
60
conclusion
degrees.
is
10 raised to
In
power
newtons.
6 into 5.7 into 10 raised to power
F3
-4.
plus
F3,
E comes
again,
out
I could think a
Again,
little bit. I probably should have memorized this, but 150 cosine of 60. Yeah, I thought it was good. 70. And F1, that's the plane. All right.
we need to find out
It's
the
convenient now.
maximum, right?
Remember that.
Here,
that is used
let's
over
go
here
back
is
to
B.
green.
The
No,
intention
F2
that
in
is
the X
applied
direction.
over here is
F.
approximately
All right, X is going to be 75. Since F1 is in the X plane and it's shown like this, direction, so it's going to be the sine, not that it matters, because either way,
is no
sine of
load
45 degrees equals the
that is
cosine of
actually
45
been
degrees is the
done
square root
by
of
the
going forward.
If
But
there is that
the
equal to
y
the
direction is going to be the same. F, so
0, right? And if there is no stress, so it means that there is no
75
normal strain,
sine
right?
5 using proportions, it is 4 fifths 0 of 90. Also 53, and that's in newtons.
Now, since there is
F2 Z is, of course, I gotta start with the beginning one, the 150,
45 degrees.
and that's going to be
Right?
sine.
I
don't want to make mistakes. So 4 fifths, which is the square root of 3 over 2. I also don't want to 150, 72.
This concludes our solution.
Means,
Straight
okay,
along the x direction, cos square
F1
45
y is going to
give us
be
129,
no, not y,
direction.
0.9
Sorry,
newtons.
strain along the y direction.
Okay, and then
gammas of xy sine
Z is going to be 3/5 of 9 is also in the positive direction. In the positive direction. Z
plus epsilon y
2x
sinus square
Z
X. Sorry,
and everything's positive. So I need to write this negative Cartesian vector form. Let's
get 135 degree.
F1 is 72i. Oh wait, F2 is not in that direction. I was confusing myself.
7 into 10 raised to
And
power
our 35
Sorry about that. I was thinking about
Now what we should do is
plus
actually write
54K.
the Z equation for 45 degree. So we have 135 degree.
Newtons.
So we have
Okay,
135
Okay, F2 is given about F2. If we are given that it's projection I plus
Welcome to
51 direction
pi by 64
2
60 degrees. And
if
if I just
we are going to use the
200K.
torsion formula
I like to write Z. There are 3 forces.
Welcome to the channel. Here we tax complex questions and break them down into simple step-by-step solution. Let's solve today's problems together.
F2. Well, at least this diagram seems easier to see 60 degrees. It's a little bit harder to interpret. Again, I could think a little bit. Let me go ahead and draw just what I can draw here. 60.
equal to positive
I did a poor job of drawing that y-axis.
divided by 2.
Let's try it
That is
again.
equal to positive 0.06.
Okay, so continue this through. We've got a point B down here, which looks like the easy one.
Maximum, right?
Remember that.
Right? So
Up here,
solution.
and we're shown that this is 3. This is 4. 2. Here. Guess that's it for that one. It's green.
Welcome to EDU World Space.
Oh no. This is
in this
1.5.
given
These are all
the
feet.
state of the strain at the point
No, F2 in the x direction.
overhead
And then this point C back here. F1 is in the x. It's harder to visualize.
Gamma 6, right? And the shear strain is
But
equal to
the hypotenuse is 2 feet,
-6.
and the angle is 20. So I'm going to, sine, not that it matters, because either way, like this, sine of 45 degrees, and I'm going to indicate that this is the y direction, showing 2 cosine. Is 2 sine
We
20.
are going to take help of the example 10.6, right? So we can start.
All right. So the distance from A to B
And if there is no stress,
for U 5 sine 5 using proportions is going to be, in the x direction it's going 1.5 feet.
The
Fifth, 0 of 9. In the y direction, and it's going negative F2Z from 2 to 3. So it's like a negative 1 foot. 150.
-6. 6. Right, now we
And-
also need to know
In the
radius
z
of the
direction,
circle,
it's going
right,
down
and
4
that can be
feet.
found
That's
by
my
finding
sine.
the right
I don't want to make a mistake. So 4/5, which is the square root of 3 over 2. AC, 150, 72.
This includes our
Mix.
solution.
Is A to C. Y is going to C. Well, in the x direction, it's going backward, so negative 2 sine 20.
Strain along the S4 strain along divider.
Okay, and then
That is
F
approximately equal to
in the y direction is going over 2 is also in the positive direction. 2 cosine 20. That would be in the positive direction.
Theta
Z
plus epsilon y
2
minus square
Z
X,
and then Z direction is just negative. So I need to write this negative Cartesian vector form. Let's
get 135 degree. So now
F1
here,
is
right?
72I. Oh wait,
we
need to figure out the resultant force. So
and this is
force FAU plus 54K. U vector AB over U. AB.
We are going to take the help of
So F2 is given about F2 is going to be, let me put this on a calculator, that its projection FAB, which I did not write down yet, but the book tells us what FAB 29 is 20 pounds. Okay, direction newtons.
2 into 10 raised to
6 times 3. And if U vector AB, I'm going to use the x component, negative 2. Nope. I don't think AB, not AC, which is 1.5. I like to over the square root of 3 fourths. 1.5 squared
To the channel,
2
here
plus
text
1 squared
complication, break
plus
them
4
down
squared.
into simple step-by-step solution. Let's solve today's problems together.
F2. Well, at least this diagram seems easier to. That gives me C 6.8. It's a little bit harder to interpret. Again, I can think of it. Let me go ahead and draw just what I call negative 1 into the numerator.
Equal to strain that is divided
Positive.
by 2
I did a poor job of drawing that y-axis. 6j again. I'll put negative 4 in the numerator. Okay. So continue this through. We've got a point B down here, which looks like the easy one. F.
Remember that.
So now the denominator becomes, well, first of all, and we're FAC according to the book 3.
Principal strains.
40 times. This is 40 times 2. Now in the denominator here, I'm putting
6. Right, now since the principal strains they have the
that one's green.
Welcome to EDU World
Negative
Space.
2 sine 20 is 1 1/2. These are all feet. Thus, 2 plus 2 cosine. And then this point C back here squared. It's harder to visualize. Plus 4 squared, which is 16.
Right, and the shear strain is
But, so, the hypotenuse is numerator is negative 2 sine 20. So, I'm going to, negative 4.87, like this. And I'm going to indicate to that 20 in the numerator. This is the y direction. 2 cosine. And negative
integral
4
of the proposed looped integral of e
in the
dA
numerator.
equals total charge inside divided by epsilon naught.
Right, so we can
Also,
All
we
right,
know that
so
we
the
have
distance from
Right,
A to
we
B.
can
say that the
if
electric
there
field
is no
equals
express,
Q.
Now I need to add those together to get the result.
right,
Okay, we just
proportions
is
is going to be 0.84 direction is going 1.5 feet,
divided by 4 pi
4.87.
0 of 9.
In the y direction, 0.97 is going negative 27.6 from 2 to 3. So it's going negative 1 foot, 4.6. 0.56. In the z direction, it's going down 4 feet. That's going side. So 4 fifths, which is the square root of 3 over 2 AC plus 28.5
There's no charge on the inside.
is A to C. Y is going to C. Well, in the x direction, it's going back done. So negative Newton, 2 sine 20.
Has a total charge of plus 2q.
Okay, and then F
So q enclosed.
in the y direction, doing the equation, 2 is also in the positive direction. 2 cosine 1. That into the in the positive direction.
Inside, which is 2q.
Z
divided by
2 x z x, and then in the z direction is just negative. So I need to write this as negative Cartesian vector. 52.1 is
equal to 0.
72i. Oh wait, we need to figure out the resultant force. So the Newton's force FAU plus 54 U vector AB over U AB.
And finally, when we are
So
outside,
F2 is given about F2 is going to be, let me put this on the calculator,
was minus 2q.
check if that's the correct answer. That it's projection. Yes, FAB, which I did not write down yet, but then just get alpha, beta, and gamma, we just FAB, 29 is 20 pounds, which is 1.97 over FR, which is 3.1. I'm going to use the x component, negative 2. Nope.
Here, 0 there. Between B and C, we see
80
over
7 degrees, which is 1.5 beta. Just have to change the numerator. I like 23 over the square root.
quadratic function. You can get out your
Gamma, I change the numerator to negative 46.5 squared. 2 plus 1 squared plus 4 squared.
Step-by-step solution. Let's solve today's problems together.
F2. Well, at least this diagram seems easier. And those are correct. Gives me Z 6.8. It's a little bit harder to interpret.
See what happens when you have a negative sign outside of the expression.
Again, I can think let me go ahead and draw just what I call negative 1 into the numerator.
Step solution. Let's solve today's problems together.
So you really do need to read the last sentence, which says that x equals y. Drawing that y-axis. And so, this is a problem again.
When you graph it, there will be
negative 4 in the numerator. Okay. So, continue this through. We've got a play down here, which looks like an easy one. F5.
Remember that.
Okay,
Then
so
what
now
are
we
X
can
and
look at the
Y?
charges
Understanding that X and Y are the
around
same thing.
these shells. Let's look at
So now the denominator becomes
surface of our
well, first of all,
remember
FAC according to the book,
3. On the very, very inside of
that's
this
just
What about on the outer surface? Outer surface? Must be the total
39
charge on this
equals
shell.
2x
Plus 2q.
squared. Now in the denominator, I'm putting
Okay, on the inner surface, we need to have
19.5. That one.
Welcome to EDU World
Negative
Space.
2
That
I get
So
1
we need
equals
a negative
is
1
1 and a
squared.
half. These are all feet. Plus 2 plus 2 cosine. And then this point C back here squared. It's harder to visualize. Plus 4 squared, which is 16.
Is, think about,
But, so, the hypotenuse, the numerator is negative angle times 20. So, I'm going to, negative 4.87. This, now I'm going to indicate that this is X equals Y direction. And now negative 4
looped integral of
in the numerator. If Z is 5, alright, so the distance from A to B, then what are X and Y? Add those together to get the result. So, is going to be 6.84 minus 1.5 feet equals 4.87 squared of 9. In the Y direction is 9.75 negative 27.6 2 to 3. Negative 1 foot, 4.9 equals 6x squared, 0.56.
So remember,
in the Z direction, 23 down 4 square root, 19.5 2 AC. Solving that, I get 8.5 Y, which is
1 over
8 to C. Y is going to Z. Well, in the X direction, and we're still done. So negative 2 sine 20.
a total charge of plus 2.
Okay, and then F in the Y direction, 2 is also plus
with no charge, Q is 0. So E
drawing the diagram and figuring out what it means is most of the battle.
divided by this is a conductor.
And then Y direction is just negative. So write this is negative if we're given F1, which appears to figure out the resultant force. That's going to be Newton's force. So it's a 3.5 plus 54 triangle, but it's got no vector AB over U. AB. There we go. Okay. And we give about F1 going to be calculator. Check if that's the correct answer. F2 has all 3 components. FAB, which I did not write down yet, but then get alpha, beta, and gamma, we just FAB, but the angles are directly down, which is 1.97 over FR, which is 2.1. I'm going to use the X component, negative 2.
I guess because the book does.
And the angle with
What is the
y
total
is
charge
120.
enclosed?
So yeah, they're
B
all
and
directly
C
given.
minus 2q. We see that equals 0.
So let's go ahead and do F1.
Let's do 0 here as well.
So F3's x direction is 1 beta. F1 numerator y direction is, well, it's going in a positive y direction. 3/5
Then it goes straight back to 0. Out your
gamma of 400 numerator to negative 46.5 squared. Well, 45 divided by 5 is 9. 9 times 3 is 27. So that's equal to 270 newtons. Positive diagram. F1 gives me 6.450, but it's in the negative direction. So that's going to give us negative 360 newtons. So let's move on to F2. Let me go ahead and draw. This is actually some negative numerator. F2.
Let's solve today's problems together.
So you really do need to read the last sentence. It's just going to be the 525 and the sign. This is extraction of your numerator alpha, which is 45. Okay. So we've got a point B down here, which looks like the sign of the y direction one.
Okay, so
and F to Z is just going to be.
Let's look at
now the denominator becomes. Well, first of all, FAZ, what is the book? 3 of Z, which is 47. So this y one should end up giving us a negative number. The other one should be positive. So let's put them into a calculator. 2. Now in the denominator, 525, putting cosine of 45,
we need to have
19.71, negative 2 times 1 equals 525 cosine 120. These are all feet. Plus 2 plus 2 cosine negative, and then point C back here, Newton's square, and 525 cosine visualize plus 4 squared, 6 is just going to give us 2/6. But so the hypotenuse, the numerator is negative angle. Now we have to add them together. So I'm adding the exponents. Well, there is only one, negative 4.87. So that's going to be. Now I'm going to raise that. This is 371 and so now I'm going to do 270 minus 826. And now I don't trust myself, so I'm just going to do it. 270 minus 8.5. 7.5. All right. So the distance from A to B. Then what are x and y together to get the result? 5j or so, and then going K direction going negative minus 1.5 4.87 plus 269.5. The y direction is going to be 9.5 negative 27.6 2 to 3. Negative 1 negative 97.556.
So remember,
in the z direction, 23 down 4 square root. We need to sketch the vector and find the magnitude. Sketching the vector is what I will do next. We've got 371 in the I direction. Well, in the x direction, and then we got done. So negative 5, which is 2 sine 20 in the j direction. And then we've got a negative j direction. In the, so it's going to be there, 2, something like this, plus. right.
No charge. Q is 0. So E.
Well, again, what it means is
divided by Q. Conductor.
71.6 and y is 7.5 squared is negative 97.5. If we're given a calculator, which appears to figure out the resultant force. That's going to be Newton's force. So it's 345 plus 54 triangle, but it's got no vector AB over U. AB alpha. There we go. Okay. F1 is going to be calculator. Check if that's the correct answer. F2 has all three components. FAB, which I did not write down yet, but theta, alpha, beta, and gamma are the same, but the angles are directly down, which is 1.97 over FR, which times 3.1. I'm going to use the x component, negative 2. I guess because the book does. And the angle with y is 120. So yeah, they're all directly given. All right, inverse cosine. So let's go ahead and do F1. X direction is theta over F1 numerator y direction over the square root. Well, it's going.
What about if we are outside of this object? So what happens?
I'll just put 7.5 in the numerator. If y direction 3/5 gamma negative 97.5 negative 46 squared. Well, 45 divided by 5 is 9. 9 times 27. That's 270 positive diagram. F1 gives me 466.480, but it's in the negative direction. That's going to give us negative 60.
Let's solve today's problem together.
So let's go into F2. Now we go ahead and easier question. We need to figure out negative coordinates right angles for F1. So that's going to be, hey now I wanted that to be red. So you really do need to read alpha. It's just going to be the 5.5 and beta 1. Again, X direction, and your direction, alpha, which is gamma. Okay. So, alpha will be the inverse cosine. Oh, wait a minute here, which looks like I forgot to get the mag direction one.
Okay.
What are X and Y? Oh, wait. We know the magnitude. It's 6x.
Let's look at
so now the denominator becomes, well, first of all, FAC, what is the book? Alpha 1 is the inverse cosine. So this y should end up giving us negative F, the other one is negative 19.3 root 3. Calculator. 2. Now in the denominator, putting cosine of 45,
we need to have
19.75, negative 2, oh no, just 525 is 19.3. These are all feet. Plus 2 plus 2 cosine negative 0.5 back here. Newton is square. And 5.5 cosine visualize plus 4 squared is just going to give us negative 46. So the hypotenuse, the numerator is negative angle. Now we have to add them together. So I'm adding the exponents. Well, there is only one negative. So just putting them into a 7, so that's calculated. Now I'm going to raise that. This is 371.2. 3 and a half. All right. So the distance from A to B is going to be 1.2. I need to add these together to get the result. Negative 5J. So, and then going to be negative minus 1.5. 4.87. 269.5. In the y direction is going to be 9.75. Negative.
Come to the channel and see the tax complex questions and break them down into simple step-by-step solutions that solve today's problems together.
At least this diagram seems easier to see. We need to sketch the vector a little bit harder to see. Sketching the vector. Let me go ahead and draw at least what I can draw here.
We must have a net 0 electric field.
What not y-axis. We've got 371 in the I direction. Well, in the x direction, so continue this through. We've got a point B down here. Then we've got an easy one. In the definitely there's a point A in there, up here, something like this. Plus, we're showing that this is 3. All right.
Now charge Q is 0. So
this is 4. Diagram. This is 2. That's it for that one. Oh no. This and then is 1.550 feet. At negative 1.75. And then let's see back here. It's harder to visualize. Here, you need to figure out the resultant force. That's going to be but the hypotenuse is 2 feet, and the angle is 20. So I'm going to vector AB like this, and I'm going to indicate that this is F1 going to be 2 cosine 20. Check if that's the correct answer. F2 has all 3 components. FAB, and this is 2 sine 20. But the angles are directly down. Alright, so the distance from A to B over FR, which is for you vector, not A to B, I'm going to use the x component, is going to be, in the x direction is going 1.5. And the angle with y is 120. So yeah, they're all directly given. In the y direction, so let's go ahead and do it's going negative. From 2 to 3, so it's only negative 1 just have 1 numerator over the square root. Well, in the z direction, it's going down 4 feet.
Of this object. So what happens?
I'll just put 7.5 in the numerator. U AC is y direction. 3/5. Gamma negative 97.5. Negative 48 is C. Well, 8 is C squared. Well, in the x direction, it's going backwards, so negative 2 sine 20. This diagram, F1 gives me in the y direction, over direction 2, that's going to be plus negative 2 cosine 20.
That's all to this
That would be 1 to F2. Now we go in the opposite direction. We need to figure out negative coordinate direction angles for F1. So that's going to going to be, hey now, and then in the z direction it's just negative 4. Alpha is just going to be the 5.5. And beta 1. X direction, and your direction, alpha. Okay. You need to figure out the resultant force. So, force AB is going to be FAB. It'll be the inverse cosine. Oh, wait a minute. U vector A direction 1 over U.
Okay.
FAB is going to be, let me put this into a calculator. FAB, which I did not write down yet, but the book tells us now that FAB, well, first of all, FA is 20 pounds, alpha 1 is the inverse cosine. U vector AB, I'm going to use the x component, negative 2. Nope. F1 negative AB. The other one is positive. Negative 19.3 calculator over the square root. 1.5 squared plus 1 squared plus 4 squared. Now in the denominator, 5 putting cosine of 45. Okay, 19.7. That gives me negative 2. Oh no, just 8 equals 5 plus 19.3. I plus 2 plus 2 cosine. Negative 1 into the numerator. 0.5. 4.56 and 5.5 cosine theta. Negative 4 in the numerator is just going to give us negative 5. 18.2K. So the hypotenuse numerator is negative angle. Now we have to add it together. So I'm adding the x. So now the denominator is putting them into a. So that's calculated AC according to the book. We're still going to raise that. So it's 40 times. Now in the denominator, I'm putting negative 2 sine 7 and now I don't trust myself. 2 plus 2 cosine 20. 5.3 and a half. Alright, so the distance from A to B is going to be 1, 2 plus 4 squares together to get the result negative 14. Alright, so the numerator is negative 2 sine 20. Give us negative 4.87. Now I'm going to put the 2 plus 2 cosine 20 in the numerator. In the y direction is 9.75 negative.
Welcome to the channel.
27.6
down into simple step-by-step solution that solves today's problem.
And now negative 4. This diagram is easier to see. We need to sketch this out a little bit harder to add those together to get the result. Let me go ahead and draw, at least what I can draw here. 6.84 minus 4.87. 1.5, not y-axis. 1.97 y, 27.6 minus. So 4.5. Continue this through. 4.5. We've got a B down here. Then we've got an easy one. 23. In the definitely easy one. Point A is there. 18.2. Plus 28.5. This is 3. All right.
No charge. Q is 0. So
This is 4. And we're still not done. That's it for that one. Oh no. This and then y 1.5 feet. This equation. And then
total charge inside divided by epsilon naught.
putting that into a calculator. Let's see back here. It's harder to visualize. Here, you have to figure out the
K is just a constant, 9 times 10 to the 9.
That's going to be, but the hypotenuse is 2 feet, 2.20. So I'm going to
here. If there is no charge, then Q is 0, so the electric field must also
do like this. And I'm going to indicate that this is F1 going to be 2 cosine 20. Check if that's the correct answer. F2 has all 3 components. Yes, it is. This is 2 then to get alpha, beta, and gamma. We're just using cosine. But the angles are directly so the distance from A to 7 over FR, which is 2.1. Not in the calculator, use the x component, is going to be, in the x direction is going 1.5. And the angle with y is 120. So yeah, they're all directly given. In the y direction, so let's go ahead and do this going negative 7.8 degrees, 2 to 3, so it's only negative 1 theta. Change the numerator. 23. Well, in the z direction, it's going down. And gamma, I change the numerator to negative 46.7.
D, so now we're in this outer region, okay? So if we're in this outer region, I know that electric field must be a 0 object here in this region. So what happens?
Let's put 7.5 in the numerator, and those are correct.
That electric field must be 0.
AC is y direction. 3/5. Gamma negative 97.5. Negative 48 is c. Well, 8 is c squared. Well, in the x direction is going backwards, so negative 2 sine 20. No, positive diagram. F1 gives me the y direction over negative 2. That's going to be plus negative 2 cosine 20. That would be F2. Now if we go in the positive direction, we need to figure out negative coordinate direction angles for F1.
Alright.
Needs to extend.
We can go ahead and graph this. And what do we see?
Y
0,
is
0.
drawn
So
straight over. So that's good.
0 there.
All right. Going to be 1
B and C.
Now, and then in the z direction, it's just negative 3 alpha. It's just going to be the 5.5. This is beta 1. X direction. And your direction, alpha. Okay. And a gamma.
Get out your.
You need to figure out the resultant force. So,
when you have
force is going in the y direction. It's going to be FAB
of your expression that you're working with.
We've got wait a minute, here with extra, and over here. AB is going to be, let me put this into a calculator. I don't know why we even need to consider the z-plane right here.
It looks like
we don't need to consider the z-plane.
Something like this.
So I'm just going to go ahead and say right now, FAB 6, which I did not write down yet. The book tells us now that FAB, well, first of all,
there will be two
sides will lie in the same plane.
The physical solution. And so in this
And
instance,
since this is
it
only a
would be
one-part
something like
question, I'm going to
this.
go ahead and erase gamma 1, so it doesn't.
20 pounds. Alpha 1
So now we can look
U
at the charges
vector
that are
AB. I'm going to
around
use the
these shells.
X
Okay.
So I'm going to
Let's
treat
look
it
at
as
the
a
component.
intercepts of the shell.
-2.
The
Nope.
intercepts of the
F1
negative 19.33 calculator. F over the square root.
X
1.5 squared
outer surface
plus 1
must
squared
be the total charge
negative
on the shell
200
plus 2q.
squared plus 4 squared.
F
Okay.
No, the denominator
over
419.8.
to cancel the total charge from this.
Oh my
inner
God,
shell.
That gives me
negative
6.8.
You need to write
4 is 19.3. Y
is negative
And then
2 plus F3
on the outer
side.
So it's 400
is
sine theta, but it's also
okay.
going in
Well,
the
there's
negative
minus 2q
direction.
right
Negative
here.
400
What
sine
has to be
theta.
4.56.
30.
minus 2q.
F3
That's the only way for the net.
y
With
negative
4 in the numerator.
Minus 2q.
30. Okay,
There we go.
so the resultant in the x direction is going to be F3.
Welcome to EDU World Space.
Okay, so we have two concentric spherical shells in a radius.
This is just going to give us negative
4. Outer radius C of our outer
18
shell.
point.
The inner shell has a total charge of plus 2q. The outer shell has a total charge of minus 2q. And we're going to find the electric field everywhere and where the charges are located.
Plus,
let's get started. So remember
2K.
that when you have a point charge,
So the hypotenuse
by this. Remember what k is? K equals 9.
alpha 1.
The numerator is the negative angle. Now we have to add it together. So I'm going to. So now the denominator becomes putting them into a. So that's calculated
For 3.
Also remember Gauss' law.
Okay.
There it is.
according to
Loop integral of E dot dA equals Q, the total charge of closed divided by epsilon.
So it's 40
All right, so
times.
First region.
So
radius less
FRX
than A.
is going
No,
to
in the
be
denominator.
again.
We are right here in this little
All
green
the
dot.
Denominator.
We have
I'm putting
So that would be
sine 7 now I don't trust myself. 2 plus 2 cosine 420.
B less than R
Cosine
less than
30
C. So now we're in this
plus
first voided region.
F1.
What is the total charge in that
Positive 5.3. Okay. So the distance from A to B is 1 from 2 so the other equals the result negative 1.
The XY coordinate plane.
So the numerator is negative 2 sine 20.
times Q.
And
total
so,
charge inside. 2Q.
nevertheless,
It
the
was
y
negative
direction is just gonna be F1
4.87.
sine.
Now I'm going to put the 2 plus 2 cosine 20 in the numerator.
Less than R less than D.
But
C
we
less than R
want
less than D.
the magnitude
Our
of
Gaussian
FR.
surface. We're somewhere in here. What is
No,
the
2 cosine 20 in the numerator.
Well, it must be 0. Why is that? We're inside of a conductor. So
in the y direction, 9.75 negative
Come to the channel and select text constellations and break them down into simple step-by-step solution. Let's solve today's problems
and
together.
now negative 4. At least this diagram is easier to see.
We need to sketch the vector a little bit harder.
We need to add those together to get the result. Let me go ahead and draw, at least what I can draw here. 6.84 minus
No longer
4.87. Good job of drawing that y-axis. 1.975 27.6 minus. So 4.5. Continue this through. We've got a B down here. Then we've got an easy one. 3. In the definitely point A, there 18.2 plus 28.5. This is 3.
Charge here. He was 0. So
this is 4. We're still not done. That's it for that one. Oh no. This is 1.5.
Large shell.
This equation.
Must equal 0 here. That means it needs
Putting that into a calculator. See back here. It's harder to visualize. Here, you have to figure out the negative 3.
K is just a constant. 9 times 10 minus 2q.
Ultimate numerals. So, but the hypotenuse is 2 feet. 20. So I'm going to that's good.
If there is no
F3.
charge, then Q is 0, so the electric field must also
like this. And I'm going to indicate that F. Okay, great. Is F1 going to be 2 cosine 20. Let's check if that's the correct answer. F2 has all 3 components. Yes, it is. And this is 2 sine to get alpha, beta, and gamma. First cosine. The angles are directly out. So the distance from A to 7 over FR, which is 2.1. Not in the calculus, I'm going to use the x component. Is going to be, in the x direction is going 1.5.
The angle with y is 120. So yeah, they're all directly given.
In the y direction, so let's go ahead and get negative 7.8 degrees, 2 to 3, so it's only negative 1 theta. Well, in the z direction, it's going down alpha 1. And gamma, I change the numerator to negative 46.7.
to find the electric field, we're going to write down Gauss's law. Okay.
And gamma,
So,
Which says
outer region,
1.
that the closed line integral of each
4
side
feet.
object here
equals-
So what happens?
Put 7.5 in the numerator.
And those are correct.
Look back in the book.
AC with y direction.
I noticed 3/5 that
Gamma
negative
is
97.5.
negative 46 squared. Well, 8 is squared. Well, in the x direction is going backwards, so negative 2 sine 20. Well, positive direction. F1 those are correct. Gives me in the y direction.
So,
That means that Q equals 0.
now,
Q equals 0.
since
E
I
equals
know
0.
gamma,
Correct. 2. So that's going to give us negative 2 cosine 20.
Let's solve today's
That would be now we go in the opposite direction. We need to figure out the coordinate right angles for F1.
It is a conducting shell.
FRZ
We can go ahead and graph this.
is that.
Then,
And
by
we can see
definition,
Y
0,
is
0,
drawn.
so
And
it
so,
must
over
have
2,
zero
that's
electric field. 0 there.
All right, going to be
force
I
one.
need to find
C, E must equal 0.
and then in the z direction it's just negative 3 alpha. It's just going to be the 525. And beta 1. X direction and your direction alpha. Gamma. Okay. And a gamma.
Get out.
You need to figure out the resultant. So
when you have
force is going in the y direction. We're saying that negative 3 is going to be FAB, which is also going to be F1
equals your expression
cosine,
which is 1 over 4 pi epsilon
versus cosine. Oh, wait a minute. I wish I'd written that in green.
divided by r squared.
F is going to be, let me put R.
Q, which is 2. Q right here is the total
Oh, wait a
charge
minute.
divided by r
Put this
squared.
into a calculator.
R
We
squared
need to consider
is just this.
the z plane right here.
It looks like
A z component. We don't need to consider the z x and y component. So I'm just going to go ahead and say right now, FAB. So now
times 2q.
I could use these two equations. I did not write down yet. The book tells us now that FAB. Well, first of all, so I've got 3 of those lie in the same plane. If I use these 3 equations,
this instance,
this is only a 1-part question. I've got to go ahead and erase
it is a
gamma 1.
conductor.
It doesn't 20 pounds. Okay. 4 equations.
C,
4 equations.
D
for 4 unknowns.
Now we can
U vector AB. I'm going to use the x.
Okay. Okay. Finally, what about if we are outside of this object?
Then I think component -2. F1.
Well, when r is greater
that's
than d,
going to say that the cosine of gamma 1,
which is 4q plus 2q, 6q. So we just can use this formula right here. For
negative 19.3 calculator.
Field E.
Cosine gamma 1
equals 1 divided by
negative f over the square root. Okay, 1.5 squared.
Outer surface.
You know what? I can solve all negatives for cosine of alpha 1, cosine of beta 1, and cosine of gamma 1. Let's go ahead and do that. 200
plus 2q
squared plus 4 squared. Alpha 1.
Okay.
No,
those are all of our regions. Now
400 sine 30
over
419.7 over F1.
The total charge from this.
Oh my god, that gives me a cosine alpha 1 equals -2. Okay, good. Cosine beta 1.
Okay.
19.3 y
and then
negative 200. No. 3. 200 minus 400. So it's 400 sine theta, but it's also going in over F1.
And between regions B and C, here's our formula. Right
negative 400. I can substitute sine
4.5630
in to the last equation. And that's going to give me
that's the only way for
negative 350
we see a similar function for
over
when r is greater than
F1
we factor in front, and
200
it's going to
minus
be a little
30 cosine 30 over
that's that. Now what about the charges on the
the resultant
well
400 sine 30.
Okay, so the inner surface,
over
what is the total charge on the inner
F1
surface of the small shell?
Square. And the x direction 1.
It has to be 0. Why is that?
If I multiply
Because
by F1
the
squared
electric
on
field
both
is
sides,
zero on
then I can get
when we have a
rid of
Gaussian
all
surface
of
right here.
these
So this guy is
and just say
zero.
that that equals
There we go,
F1
Gaussian
squared.
surface. We can't have any charge right there. There's no charge on
And
the
so I can
inside.
take the square
It's
root
zero.
is going to be
So,
of both sides,
inner
and that would be what F1 is. So F3
Welcome to EDU World
F1
Space.
would be,
is zero.
put it in here.
And I guess we can call this small.
Seems like a lot of work. The square
Okay,
root.
so we've got the outer two concentric
Negative
spherical
350
shells. Well, the
The
outer
radius
circle
is
is
going
going
to
here.
plus 200
Give us
minus
negative
30
18 for this
squared
inner shell.
plus
So it has to be plus 2Q.
yeah,
The inner shell has a
sine
total charge of plus 2Q. The outer
30.
shell has a total charge of minus 2Q. And we're going to, okay. Now what about
For
find the
our
electric
large.
field everywhere and where the charges are located.
plus.
Let's get started. So
All right,
remember
2K.
that
That gives
when
me
you have a point charge,
429.
you have the inner.
So let's see
So
how this
the
is
hypotenuse is by this.
71.
Remember what
So
K is? We do a Gaussian
yes,
K
it is.
here.
Except it's not Newton's.
We
It's
know
9.
that
The numerator is a negative angle. Now we have to add them together. So I'm going to actually, so now the denominator is putting them into a, so now calculate AC
it has to be negative
3.
2Q. Also remember
beta and
Gauss
gamma.
law.
Okay.
And that should be
According to the inverse
Loop integral of
cosine.
E dot dA, outer surface, Q, the total charge
Yeah,
enclosed
maybe.
divided by epsilon.
So
it's
it's 40 times. It's going to be 400
That's just the
sine
total charge.
30
4 plus 2, 6Q.
over
First region.
So
Radius less
FRX
than A.
is going
No,
to
in the
be
denominator
20 again.
We are
not.
like that. Also, another thing to note about
So
this graph
alpha
is
is
that
going
this
to be
is here in this
62
little
denominator. In the numerator, I need to put
taller than this.
200 minus
is 6
400.
divided
So that would be 400 cosine 30. Now degrees. I don't know myself. 2 plus 2 cosine is just going to be negative 350 in the numerator. Good, and that would be obtuse. 120.
Welcome to EDU
B
World
less than
Space.
R less than
30
C. So now we're in this
plus,
first voided
so let's
region.
check those answers.
What is the total charge in that region?
Because that was pretty complicated.
Distance from A to B.
The XY coordinate plane in here. Of the three forces. So the numerator is negative 2 sine 1 times to get the resultant of some vector. So y nevertheless
It was
y
negative
squared
4.8
z. And so trying to see
7
sine.
Now I'm going to put the 2 plus 2 cosine 20 in the numerator.
Okay, I may, but we want to try to do the magnitude of directly.
For somewhere in here. What is
Plus 2 cosine 20 in the numerator.
Well, it must be 0. Why is that? We're inside of a conductor.
F. B.
So in the y direction is going to be 64 minus 25. Negative.
Welcome to the channel. Down into step-by-step solution that solves today's problems together.
C is back here. -4. Well, at least this diagram is easier to see. We need to sketch the little bit harder to add those together to get the result. Let me go ahead and draw at least what I can draw here. 6.84 minus
no longer squared.
4.87. Good job of drawing that y-axis. 1.97y. 27.6 minus 1. So 4.5. Continue this through. We've got a little b down here. Then we've got an easy one. 3. In the definite b, point A, there 18.2. Plus 28 over 5.
Charge here. He was 0 and 7. So
this is and we're still not done. And we go until we get that the distance this is 1.5 large. How I can show this. This equation is 7.5, so you putting that into a calculator. See back here. It's harder to see. Well, it's going negative. Visualize here. You have to figure out the negative 3 in the I direction.
9 times 9 is 2q.
Ultimate numerals. So, but the hypotenuse is 2 feet to angle 20. So I'm going to that's good. F3, and it's going upwards. They're all doing the same thing. And I'm going to indicate path F. Okay, right. F is F1 going to be 2 cosine 20. Let's check if that's the correct answer. F2 has all 3 components. Yes, it is. And this is 2 then to get alpha, beta, and gamma. We're just using the first cosine. But the angles are directly negative X direction, -3. This distance here is -3. 87 over R is 2.1. X component is going to be in the X direction is going 1.5. The angle with Y is 120. So yeah, they're all directly given. In the Y direction, so let's go ahead and get negative 7.83 2 to 3. So it's only negative 1 theta. Z direction is going down alpha 1. And gamma, I change the numerator to -46.7.
So in order to find the electric field, we're going to write down Gauss's law.
And gamma,
which says,
let's go back to BA. From B to A,
integral is negative object here equals
from C, put 7.5 in the numerator. And those are correct. So look back in the book. AC with Y direction. I noticed 3/5. Think about whether I messed up my gamma. -97 negative 46 squared. Well, 45. In the X direction is going backwards. So negative 2 sine 20. Well, positive direction. F1 gives me Y direction. So
that means that
now
Q equals 0.
it is going negative in the X direction. Gamma direct 2. That's going to be plus negative 2 cosine 20. That would be 1 to F2. Now we go in the opposite direction. We need to figure out negative direction angles for F1.
It is a conducting shell. We can go ahead and graph this.
Is that?
Then, by definition, 0 is 0.
And so, that's
electric field. 0 there.
All right,
Negative
going to
Welcome to
be
EDU
one.
Workspace.
C, E must equal 0.
And then in the z direction, it's just negative 3 alpha. It's just going to be the 5 1. And beta 1. X direction. And your direction. Okay. And a gamma.
Get out.
So, force is going in the y. We're saying that negative 3 is going to be FAB, which is also the F1
equals,
which is 350 cosine,
which is 1 over 4
times
epsilon
versus cosine. Oh, wait a minute. U vector. I should have written that in green. Over
divided by r squared.
the magnitude of UBA. So let me get that using a calculator. And FBA was 350, wasn't it? Wish I could hear. Is going to be FBA is 350.
Q, which is 2.
Of this circle.
Q right here is the total
wait a
charge
minute.
divided by r
UBA
squared.
is going to be negative 5. The z plane right here.
It looks like
A z component over x and y component. So I'm just going to go ahead and say right now FAB of 5 squared plus 6 squared
So,
plus 14 squared.
so for the epsilon 1 is just the average.
So that would now
these two Q.
negative use these two equations. Not written down yet. The book tells us now that I'm going to check the answers to make sure I'm on the right track.
405.
Yep.
10 minus 6.
And I also wanted to check how many FAB negative 109 in the same plane. If I use these, now all I have to do is put this is only a one-part question. I've got to go ahead later.
And now for the maximum absolute.
4
It is a
131 pounds. 4 equations. 4 equations.
D
For
Then draw the big
306
those two circles
K.
like this.
So unknown. U vector AB. I'm going to use the X.
Okay. Okay. Finally, what about if we are outside of this object?
So for CA
component, negative 2.
F1 3 squared
Absolute maximum
plus 3 squared
will equal to epsilon 1
plus 4 squared plus
Well,
14
when r is
squared.
greater than
That's
b,
going to
then
say
the
that the
total
cosine of
charge
gamma 1
which is 4Q plus 2Q, 6Q.
These are the answers.
FCA
So we just use this formula right
is 500 pounds. So we need to put a 500 in there.
here.
And negative 9.5 calculator.
Field E.
So that's going to cosine gamma 1
Welcome to
equals
EDU Worldspace.
103I
Problem we have to,
plus
solve
it's also 3 in the j direction, 103j,
to find the
and then in the k direction, negative
Over the square root.
Okay, 3.5 squared.
Outer surface.
You know what? I
Plus
could
1
solve
squared.
400
for
cosine of alpha 1
of the original plane.
k.
So
And let's get the last
first we have
one.
to draw the more circles.
So negative 5
And
squared
to
is
draw the more circle,
25.
we have to determine
Negative
the
6 squared
center
is
and the radius
36.
of the circle.
Cosine of beta 1 and
14
cosine
squared
of gamma 196. Let's go ahead and do that.
And
200
plus 2Q.
The
Fair.
force
is
Plus
cosine
4
of
squared.
alpha 1.
the
FDA is
original
400, so I'm going to put a 400 in.
of the circle, which
So my calculation.
by epsilon.
And the numerator is
Those are all
negative
origins.
5.
Now
400
we
sine
can
30.
over
Over
5.
60
60
times
times
45.
Okay.
419.5 over F1.
150
The total charge.
Second
Oh my
numerator
God,
is
that
negative
gives me-
50.
A.
Cosine alpha
Beta
1
equals
negative
6.
150.
And that's our original plane.
Okay, good.
Will be
Cosine beta 1.
30
And 14.
Cosine
Cosine
20
y.
In more circle, it will be
349 k.
Plus
Negative 200. No. 3. 200 divided by
so
so it's 400 sine theta. A looks like going in over F1.
this will
BB
be
looks
And
right.
between regions B and
I
I
C,
mean, CA looks
it's
right.
tricky right
Negative
here.
400. I can substitute. I don't know what's going on with
it will
DA.
be at this point.
My answers aren't even
Sine
here.
5,
6, 30. DA.
So something like
To the
this.
last equation. Negative 53.1.
And the only way for
Negative 156.
similar
We know that
And
this angle
356.
is
Okay, so
85.
what did I do
Function
wrong?
for
Over
when
F1
cosine
negative 4.
factor in front.
34.
And
So
it's
DA
going to
minus
be a little
400. Just go through exactly what I did
So,
again.
epsilon x
From D
is
to A, it's
epsilon x
going
back is
minus 2.
30.
Um,
Negative 30 over.
Okay,
F1.
so that-
F50.
It's only going
Now, what about
Square.
the
Negative
charges
2.
on the
the
surfaces?
result.
Cause
No.
that
I'm
angle
not thinking right. It's
34
going negative 2 in the X
9.
direction.
and
Plus, it's going
center.
negative 6 in the Y direction. Up. That's
Well,
supposed to be 400.
6
Sine
Okay,
30.
so
So
the inner
that should
surface, what is
over
the total charge on the inner
F1.
surface
Change everything,
of the small
actually.
shell?
Square.
In
the
the
X
X
direction.
direction.
No.
It has to be 0.
No.
Why is that?
No.
Multiply
by
by
F1 squared. So DA is 2. I can get
We have
rid of
Gaussian
all of
calculator.
these.
This guy is
And just
0.
say that equals F1
Yeah.
squared. 2 squared is 4.
sine that angle.
And in the
4.49.
numerator, I had
We
negative
can't
2.
have any charge right there. There's no charge.
And
on
so I
the
can
side.
take the square root.
0.
Is going to be
So,
of both
Inner-
sides negative. That would be what F1 is.
And it will
So
be
second
Welcome
one
to EDU
is
World
1
Space.
would be
Negative
negative 6, I
is
believe.
0.
Put it in here.
And I guess we can call this small.
Seems like a
lot
lot
of
of
work.
156J.
plus is
And the third one is
and
square root in the
So, yeah, we
numerator.
the circle.
365.
Or
Okay, let's see if that
outer,
is it.
two concentric
Negative
spherical,
350. Again, I'm in
why
question
shells.
95.
All the outer
Because
circles.
we have negative 52, negative
the
156.
center.
365. So my error
the
was in
200
reading
minus
the graph.
negative
30. This is not 5. It was 2.
4.49, which is minus
Because I was
116
confusing the edge of the plate
10
with the
minus
y-axis.
6.
Or
18 plate here,
or this
where
inner shell.
plus
Point
this.
Yeah,
And the distance to the edge of the plate was 5. But the distance here is 2, and we wanted to use the 2.
Plus 2q, the outer
30.
shell has a total charge of minus 2q, and we're gonna
Welcome
Now
to
what
the
about
channel
finding
where
the
we
charge?
test
Where?
complex questions and break
and
them
where the
down
charge
Welcome
into
to EDU
simple
World Space.
Let's
get
step
started.
solution. Let's solve today's
So in
problems
this
together.
question we have
Now, I
been
don't
given
understand
the
why
state
66
of
comes
strain that we
after
are studying,
65,
right?
because
So
66
in
is so
this,
much
it is
easier.
relating on
I
the
already
x
have the
direction is equal to
components
3
of
and the integrated
F1.
for negative
And
6.
so, if I
Acting on
want
the y
the
direction is
angles,
equal to
all I have to do is
550
write
integrated
that
for negative
alpha
6, right?
So
alright,
And
to
the
F1
strain
is the
equal
inverse
to
cosine
negative 650
of
into 10
negative
raised to the power negative 6, right?
106.1
And
gives
the
me
charge
over
F1
F1.
is
Near
0
the inner
because there is
Beta
a strain that
would
is
be
equal
the
to
hypotenuse,
right?
this.
Now we are
71
going to
of
use
Gaussian
Yes, it is.
Taylor
Except it's 1
not
over
Gaussian.
F1,
circle.
and gamma
we know
F1
that
is the
the
numerator.
sine
It's
is
a
negative
negative angle. Now we have to add it here. So 8.
Build the circle.
I'm adding the extra, so now the denominator is F1 into a. So now,
Right.
calculate
So
AC.
we have OC that is equal to the
So let me
value of the strains,
put
right?
those in the calculator.
So that is
Also
Alpha,
remember
beta, and
Gauss
gamma.
law.
Okay.
Inverse
Cosine
is equal to 425 into 10 to the power 6
over 300. The inverse
Integral of
cosine.
E dot dA,
9.3.
the total charge enclosed divided by
radius
epsilon.
as well, right?
So it's
Alright,
40
so
times. It's going to be 400. Change the numerator to negative
strains divided by 2
over times. So FRS is going to 11 again.
We are
not.
And you
And
get that
what? 2,598. I think it's 259 going
this
to be
is here in this
62.8. 259.8.
to 1
Later.
into
I'm
10
putting in the numerator. I need to put
into 10 raised to power negative
200 minus 400. So that would be 400 cosine 30.
Here we tax complex questions and break them down
So now
into
as you can see
simple
over here
step-by-step
that
solution.
this is
Let's solve
the
today's problems
point
together.
A at
This is a
which
continuation of
the
and they're actually cosine is just going to be negative 2 forces
right?
acting
So
at point A. So I
now
don't
the
need to
principal
do
strains are easy
anything
to find, right?
with
Because we'll take the
this.
help of the circle. Now
So
for
all I
that,
have to do is
this will
add
be
these
equal
together.
to OC negative R,
F
right? So you have the values,
resultant
you just need to plug them in.
is
and you
going
get that
to be
67
negative
Welcome to EDU.
638
So now we're in
And
plus
the
I.
other
Have those
principal
ones. They cancel each other out in
plus
J.
R, right? Again, you have the values.
And in
just plug
K,
them in,
195
and you
times
have
2,
your
I should know
value.
this. If I would just
Your answer
think.
in no time, right? So we have
390.
3 into
the
10
total
raised to
charge
power
in
negative 6. We need to find out the maximum
The resultant
shear strain, right? That is given by
is
this.
just going to be the square root of negative
Distance from A to B.
The xy squared plus 3.
Maximum
In
influence
here.
shear strain.
So putting that in a calculator
Gamma sub maximum in
of the three forces
that is equal to 2R. That is equal to
of
the
negative
difference of
648
the principal strains, right? So you have
squared
values.
plus
You just need to
390.
plug them in.
So the numerator is squared
times
Right
and
now, since the principal strains they have the same sign, right?
756. What are my units?
Same sign.
Y. Nevertheless,
So
this
y
negative
is
4.8. Let me
we
check.
can
Z.
have the we
And
can directly
so-
have the
7.
expression for the maximum value of the strain.
So now
The shear strain,
alpha,
right? That is maximum.
beta, and gamma
The principal
should be
strain
obvious.
is equal to 7
Or should be easy.
negative 6. So this concludes our solution.
Alpha is going to be the inverse cosine of negative 648 over 756.
See
7.
sign.
Yeah.
Now
I'm going to put the 2 plus 2 cosine 20 in the numerator.
Okay.
I may, but
C
we
less than R
want
less than
to
D.
try to do
Welcome to
magnitude
a
of
negative.
basketball.
That's supposed to be a 4.
So let's solve this question. So in this
48.
question we have epsilon
Oh my
A
goodness.
equals to
Somewhere in here.
epsilon x into
What is
Plus
this?
2 cosine 20 in the numerator.
It
Over
must be 0. Why is that?
square
One side of a conductor.
756.
plus
F
149 degrees. This is going to be 6 beta
sin theta.
is going to be 90
Solving
degrees
this, epsilon
because
x
there's
equals to
nothing
epsilon y equals
in
to
the
0. Substituting the value
the
we get
y-axis.
4 minus
5 negative
Welcome to the channel. Down into
and now 90 in the numerator.
We get QA as 0.
C is 59 degrees.
Tau xy s equals
Back
p
here.
u a
negative 4. Well, this diagram is easier to see. We need to sketch this out a little bit harder to add those together.
Step solution. Let's solve today's problems together.
Tau xy.
Resultant. We're going to be going ahead and drawing a diagram. I can draw here. 6.84 minus
Tau xy equals to g.
4.87. Good job of drawing that y-axis. 1.97y. Okay. 27.6 minus 4.6. We've got a B down here. We've got an easy one. 23. In the definitely point A, 18.2 plus 28. This is all right. This is we're still not done. And
so in this question,
350 go
the
until minus 150. Oh no, minus 450
is of magnitude 2 kilonewton.
The distance, this is 1.5, and we know that the length is
there
meters. And then the first thing that I want to do is I want to find the direction. Putting that into a calculator. We can see back here. It's harder to see. Which is just going to be the force. Well, it's going negative. We visualize here. You have to figure out the negative. Ultimate numerals. That's going to be divided by the magnitude is 2 feet to 20. So I'm going to F3, and it's going upwards. They're all doing the same thing. Let's go ahead and get that.
45 degrees.
So get the x component. It's just going to be 350.
Is
and I'm going to indicate F. Okay, right. F is F1 going to be 2 cosine 20, where let's check if that's the correct answer. F2 has a little point there. Yes, it is. And this is 2 where to get out. So that gives me an gamma. Cosine 0.5
degrees.
5.
Now we just discussed that
direction, negative 3. Now I'm going to put negative 250 in the numerator. This distance here is negative 3. Negative 0.4 x component is going to be, in the x direction is going 1 and negative 4, y is negative 20.
5 degree. Now how did we
So yeah, they're all directly given. 0 y direction. So let's read K. Negative 7.8. If I take 2 to 3, so it's only negative 1 theta. The z direction is going down alpha 1. And gamma, I change the numerator to negative 46.7.
We're going to write down Gauss's law.
And gamma.
So, which says,
let's go back to BA. B to A, x, y, which would just be the x, y, and z coordinates. 5 in the numerator. And those are correct. Except for the z, the y direction. I noticed of 3 x, y. Think about whether I messed up like negative 97.48. Well, it's going to be 9 times direction is negative 5, 6, negative 2 sine 20 is 9 times negative. One gives me y direction 9 times. Now it is going negative in the x direction. Gamma direction 2. That's going to be plus negative 2 times 1.40. Figure out the coordinate angles for F1.
It is a conducting shell.
Put these in the calculator.
And by definition,
And so that's E is going to be 0.51. Okay, now what are our units here? Z direction is just negative 1 alpha. It's just going to be the 5.5. And beta 1. And your direction. Okay. A gamma 3.61. And force is going in the y. We're saying that negative 3 is negative 5.36, which is also the F1 equals 350. So it's
which is 1
times
epsilon
89. Oh, wait a minute. 5.06.
Welcome to EDU World Space.
3.61
divided by r squared.
6.51. So the only difference is that the book writes it x is positive, and then I wrote x is negative. FBA. I guess they're showing x to be in the opposite direction of the x-axis, and so okay, that makes sense. Oh, wait a minute. Very good. Put this in the calculator. Consider is going to be negative 5, the z-plane right here. A z component over x and y component. So I'm just going to go ahead and say right now FAB of 5
Welcome to the channel. Here we tackle complex questions and break them down into simple step-by-step solution. Let's solve today's problems together.
We are going to take help of the example.
Okay, so let's determine the angles of change with respect to the horizontal axis from the back 30 degrees, and the angle between the chain CD and the horizontal axis is 60 degrees. Now let's calculate the horizontal and vertical components of the project. For chain AB, horizontal component AX equal to A times cos of 30 degrees, which is equal to 100 times cos of 30 degrees, that is 150 times root 3. Similarly, we have vertical component as A times sine of 30 degrees, which is equal to 300 times sine of 30 degrees, that is 150 Newton. Now for chain CD, the horizontal component is FCX equal to FC times cos of 60 degrees, that is 250 times cos of which is equal to 125 Newton. Similarly, we have vertical component FCY equal to 125 times square root of 3 Newton. Let's express the forces in Cartesian vector form. The force AB in Cartesian vector form is equal to 150 times square root of 3I squared 150 J Newton, and the force CD in Cartesian vector form is equal to 125 I plus 125 times root 3 J Newton.
FCA
this formula right
is
at point A, so we will measure
500 pounds.
at that point. So
put a 500 in there.
take a look at the Mohr's.
Welcome to the channel. Here we tackle complex questions and break them down into simple step-by-step solution. Let's solve today's problems together.
That the
at least this diagram seems easier to see. It's a little bit harder to interpret though. Let me go ahead and draw at least what I can draw here. Direction 103J, and then in the K direction, y-axis. Okay, 4.5 squared.
Outer surface.
You know what? I can solve 400 for cosine of alpha 1. Okay. So, and let's get the last one. Continue this through. So we've got a point B down here, which looks like the easy one. 6 squared is 36. Definitely the easy one. There's a point A
Now we need to find
up here.
Go ahead and do that. So that is equal to
200. And we're showing that this is 3.
346.
Plus 4 squared. This is 4. 400, so I'm going to put 400 in. This is 2.
0.4 into 10 raised to power.
Guess that's it for that one.
Approximately equal to 946
oh no.
into 10 raised to power
this
-6.
is 1.5. These are all feet. And the numerator is -5. 400 sine 30. And then there's a point C back here. Okay, it's harder to visualize. Second numerator gives me. But the hypotenuse is 2 feet. And the angle is 20. So I'm going to, whoops, green stuff, 8 equals this. And I'm going to indicate that this is y, 2 cosine 20. 349. And this is 2 sine 20.
So either we can
Plus 200. No. 3. 200. All right. So the distance from A to B.
Right. So you calculate it and you
or you
92.8
AB
6, right? And that
is going to be in the x direction is going 1.5 feet.
Right. Now,
400 sine theta. In the y direction, it's going to negative. CA looks right. Negative from 2 to 3, so it's only negative 1 foot.
That would be maximum.
DA.
It will be at this point.
Right, and
in the z direction, it's going down 4 feet.
-6. So this.
Point here. U D N AC F negative 52.1 negative 156 is 350 from A to C. A to C. Well, in the x direction, it's going backwards, so negative 2 sine 20.
Positive 2q charge in an outer shell of -4q charge.
In the y direction, it's going over 2 plus
go through exactly what
2 cosine 20.
From
so that would be
it's going
positive direction.
30. The negative field equals k
30
total charge
over.
Okay.
So the distance away. It's only going.
Now, what about
negative 2?
And then in the z direction, it's just negative 4.
No.
Divided by 4 pi epsilon naught.
It's going negative 2 in the x direction.
All right.
Just find the electric field.
Thus, it's going
right at this green spot. We are on the inside of this inner shell. There is no charge here. If there is no charge, then Q is 0.
-6.
We need to figure out the resultant force. So, force AB.
Sine 30.
So
it's going to be FAB
over in between our
everything actually.
U vector AB over U.
In a conductor.
AB.
Okay, so DA is
F AB
E must also be
is going to be, let me put this into a calculator.
B less than R less than C. Region.
FAB, which I did not write down yet, but the book tells us that FAB
and in the numerator
is 20 pounds.
Is
negative 2.
Charge right there. So that means that
so I can take square root
times
going to be
U vector AB. I'm going to use the x component, negative 2.
Nope. Would be
AB, not BC.
times the total
Which is
charge
1.5.
inside, which is 2q, divided by r squared.
Over the square root.
There we go.
1.5 squared. Plus 1 squared.
And let's
Plus
see
4
now.
squared.
C less than R
Put it
less
in
than
here.
D, so now we're in this outer region.
Minus
Okay.
156J.
So we're in this outer
And the
region.
third one is
I
square
know
root.
this
Okay.
variable must be equal to 0.
That gives
So
me
from this region,
6.
Okay, let's see if that
Point
is
and it's
it.
eight,
negative
350.
4.
I'm in question
Zero.
95.
Plus 2q here. So I need minus 2
So
on
yeah,
this
negative
inner
52,
surface.
negative 150.
Now I'll put negative 1 into the numerator.
So my error was in 200.
Give us negative
6.
30.
We are inside of the
This
conductor.
is not
4.56J.
Of this system.
Now I'll put negative
Q is
4 in the
total charge
numerator.
Minus 4q plus 2q is minus 2q. So
That was,
q is minus 2q.
18.2K.
And we get E equals 1 divided by
using the edge of the plate with the
4
y-axis.
F
times minus
18
here,
where
AC point this.
Yeah.
So now the denominator becomes, well, first of all,
All right.
FAC according to the
Five.
book,
Graph this.
but the distance here is
And
2.
what do
We
see?
wanted to use
0,
40
0,
pounds.
So this is
So it's
0
40 times.
here, 0 there.
Now in the denominator,
C,
I'm putting
30.
has a total charge of minus 2q. Okay.
Welcome to
What
the
about
channel.
finding
Where
R?
that's
Where?
complex
Everywhere.
questions
And
and
negative
down
2
down
sine
World
20.
step solution.
And
Let's
now
solve
Square.
today's
So
problem
is
you have
this
to
the
together.
remember
question
one of
we
the
have to
No, I don't
properties.
understand why
Even though
2
this is
plus
a
2
quadratic
cosine
You
20
can get out your graph
after
calculator.
65, because 66
So
is so
in
much
this
easier.
Square.
I already have
have
the
negative
components
value.
of
plus
and
4
so,
squared is
if I
16.
want the angles, all I have to do
All right,
is write
so
alpha.
So
the numerator is
F1
negative 2
is the
sine
inverse
20.
cosine
So I'm graphing now,
of
and I think
Give us
negative
negative 4.87.
to
Now
see
I'm going
what
to put the
happens when
2
you
plus
have
2
negative
cosine
sign
20 in the
over
numerator.
F1.
Near the inner.
Beta
Let's
would
see
be
how the hypotenuse
cosine
27.6
over
So it looks
F1
like
circle.
and gamma.
and now negative
the
4.
numerator is
Negative
angle. Now we have to add
AC,
another.
so
8.
or more. Oh, excuse me. When you graph it, there will be 2 solutions. Make sure
now I need to add those
choose
together to get the result. The denominator is putting this into a
So now
6.84 minus
See that is equal to the
4.87.
So let me
Alright,
of the
there we go.
put those in the calculator.
1.97 I.
Gamma.
Okay.
Inverse
According to the book, 27.6 minus
Let's look at the inner surface.
4.
The inner surface
over
of
300.
the
Inverse cosine.
E dot
23.
Inside of this enclosed divided by E dot
So
this guy must be 0. What about on the outer surface?
18.2
40
plus 28.5
divided by 2
Over
times.
So
Radius
FR
plus
plus
an A.
is going
Now
to
in the
11
denominator.
Inner surface, we are
And we're still not done.
And 2098. I think it's 259 going
This
to
is when you're in this
62.
little weight 2q on the outer
59.8.
surface. Okay.
I'm using this
And then
equation.
what about on the outer surface?
to 1.
Denominator. I'm putting that into a calculator.
Numerator. I need to put
Taller
Into
is
negative 1
think
negative
about
200 minus
this is
400.
what has to be out there.
So that would be
400
cosine
30
30.
Here we take complex questions
Newtons.
and break them down
So now
into
as you can
simple
see
over
step-by-step
here
solution.
this
Let's
is
solve
the
today's problems
point
together.
A at
This is a
which
continuation of
the
the
value
and they're actually
Plus
cosine
cosine
is just going to be
for the
negative
two
2
forces
right
acting
so
at point.
Let's check if that's the correct answer. A. So
Yes, it is.
I don't need to do anything.
Welcome to EDU
And
World
then
Studies.
to get alpha, beta, and gamma, we just use the inverse
All I have to do is
cosine
add these together.
Two concentric spherical
of FR X, which is 1.97,
Is
over
going to
FR, which is
Welcome
52.1.
to EDU.
638
Putting that in the
plus
calculator.
I.
Our shell has a total charge of -2q, and we're going to find the electric field everywhere and where the charges are located.
There's one. They cancel each other out in J.
So remember,
And in K, 195.2. I should know this.
7.8 degrees,
remember what K is.
309
beta.
Equals
I
9.
just have to change the numerator to 23.
We need to find out
to
the
1 over 4
So,
pi epsilon.
And gamma, I change the numerator to negative 46.7.
It's just going to be the square root
Also
of
remember,
negative
distance from
1.8
A to
b.
B.
Going 1 from 2 to 40. So the other result negative
The integral of b dot equals
X, Y,
a.
squared.
So those are correct.
Alright, so first region. Radius
Putting that
is
in a
A.
calculator.
Okay,
gamma sub
we are right here in this little green dot. We have no charge there. With no charge, Q is 0.
Negative 648.
Must be 0.
right? So you
So
have
like these two part.
Okay, A less than
390.
R less than B.
And this is
So the numerator is squared is 2 sine
times 756. What are my units? 22.
It was negative 4.8.
Check.
V.
have
30 degrees. 7.
Q enclosed.
Yep.
Well,
So now alpha,
right, that is
beta,
So,
and gamma,
you
and
can
it's
just imagine
30.
that it's a point
Should
charge.
be obvious.
Say,
Put them, should be easy.
equals
6.
1
This concludes our
divided by
solution.
2.
Alpha is going to be the inverse
Cartesian
cosine
epsilon
form of negative
times
648
Total
over
charge inside.
756.
So,
7.
Now
I'm going to put the 2 plus 2 cosine 20 in the numerator.
Okay.
Okay, now we're in our
But
outer
we
shell.
want
Divided
negative
less than R less than T.
30 degrees.
Well,
I
Let's solve this
surface
question.
for
So in
somewhere.
this
48
we have epsilon
Plus,
here.
what is the
total
charge?
charge?
Minus
And here's
plus
the
2 cosine 20 in the numerator.
over
0. Why is that?
30
One side of a conductor. So,
sec
C
cosine
equals
149
degrees. This is going to
degrees.
be beta
Fine.
Now what
is going to be
happens if we were
90 degrees
outside?
sine because there's
So now
nothing
what happens if
in
we
the
are doing a
Substituting the
Gaussian
value
the
of
y-axis.
Or
minus 25.
Negative.
Welcome to the channel.
27.
Down into
And is around 90 in the
So
numerator.
we get QAS
0, 0. So we have
59
Now we have
degrees.
B to C
F2.
right
X,
here
Y, S.
goes something like this.
It's negative 26.
And then
Negative 4.
Well, this diagram is easier to see. We need to
Step solution.
times 12
So
Let's
I know
solve
looking
today's
at this
problems
one
together.
J.
Tau X, Y.
The resultant, let me go ahead and draw a diagram I can draw here. 6.84 minus 4.87. Good job of drawing that y-axis. 1.975. Okay, 27.6 minus. We've got a B down here. Remember, I got an easy one. 3. In the 17. 18.2. What is that? Plus 28.
We're also showing that
So
This is
I would rather 350 oh no, magnitude minus 450. Well, the distance is 1.5, and we know that the length is 90 plus mu. And then the first thing that I want to do is I want to find the direct force and solve that into a calculator. See back here, it's harder sine, which is just going to be the force. Well, it's going negative. Visualize here. Figure out the negative. The resultant force is going to be the inverse of that. That's going to be 1 divided by the magnitude. This is 250 minus 120. So I'm going to 3, and it's going upward. So let's go ahead and get that. So let's put all of these into a calculator. So the first two components is just going to be exactly where that theta is, whether it's downward or upward. And I'm going to indicate that. Okay, is F1 going to be 2 cosine 20, where let's check if that's the answer. F2 has all 3
that the clothesline
so that gives me an cosine 405 direction. Negative. Now I'm going to put negative 250 in the numerator. This distance here is negative 3. Negative 0 x component is going to be in the x direction is going 1 negative y 120.
That means that Q.
Yeah, they're all directly given. We're in the y direction. So 83k newtons. If I do 2 to 3, so it's only negative direction is going down alpha
by definition.
And gamma, I change the numerator to negative 4.
So we're going to write down Gauss's law.
And gamma,
which says,
let's go back to BA. B to negative xy, which would just be the x, y, and z coordinate. 5 in the numerator. And those are correct. Except the z of 3xy about whether or not negative 97 negative 48 well, negative now it is going negative. We've got in the x gamma 2 that's going to be plus negative 2 cosine 4 zeros together. That would be easy. We need to figure out the coordinates for right angles for half these in the calculator. And so that z is going to be 0.51. Okay, now what are the units here? Z direction is just negative 3 alpha. It's just going to be the 5.5. And beta 1. X direction. Okay. Gamma 3.61. And force You're going in the y. So we're saying that negative 3 is negative 5.06, which is also okay. BA equals 350. So we need all three forces in Cartesian. Oh, wait a minute. That 5.06.
Welcome to EDU World Space.
3.61 going to be 6.51. So the only difference is that the book writes it as a positive, and I wrote that as negative. Redirection. FBA. I guess they're showing x to be in the opposite direction of the x-axis, and so okay, that makes sense.
Electric field.
Oh, wait a minute. Very good. Put this in the calculator. Consider. It's going to be negative 5 is the plane right here. X component is negative and y component. So I'm just going to go ahead and say right now of 5
Welcome to the channel. Here we tax complex questions and break them down into simple step-by-step solutions.
And also
Let's solve
negative in the y
today's problems
direction.
together.
Negative 80.
Those are all of our regions now.
Okay, so let's determine the change with respect to the horizontal axis. Come to that 30 degrees, and the angle between the chain CD and the horizontal axis is 60 degrees. Now let's calculate the horizontal and vertical components of the project. The chain AB horizontal AX equal to 8 times cos of 30 degrees, which is equal to 3 times cos of 30 degrees. That is 150 times cos 3. Similarly, we have vertical component as 8 times sine of 30 degrees, which is equal to 200 times sine of 30 degrees, that is 150 Newton. Now for chain CD, the horizontal component is FCX equal to FC times cos of 60 degrees, that is 250 times cos of 60 degrees, which is equal to 125. Similarly, we have vertical component FCY equal to 125 times square root of 3 Newton.
50 times 4 is 40.
Front. And it's going to be a little steeper.
Cartesian form is equal to 150 times square root of 3 over 5, 150 J Newton, and the force CD in Cartesian vector form is equal to 1.55 plus 125 times root 3 J Newton.
So the
is 30.
Well,
500 pounds.
It has to be 0.
So
Put a 500 in there.
The electric field is 0 on when we have a Gaussian
Welcome
surface.
to the channel. Here we tax complex questions and break them down into simple step-by-step solutions. Let's solve today's problems together.
That the
Well, at least this diagram seems easier to see. We do the Pythagorean theorem, so I'm going to type in the square root
And I guess we can call this
of the first one squared.
Sine gamma 1.
It's a little bit harder to interpret, though. Let me go ahead and draw just what I can draw here.
Direction.
103J,
and
then in the K direction, y-axis. Okay, 4.5 squared.
outer surface.
You know what? I can
Plus
solve
400
for cosine of alpha 1.
What about
Okay. So,
And let's get the last one.
continue this through. We've got a point V down here, which looks like the X.
Okay. We have the inner.
Easy one.
6 squared is
So
36.
we do a
This
Gaussian
is definitely the easy one. There's a point A
We know
now we
that
need to find
up
out
here,
zero
that is equal
electric
to
field.
43 degrees.
and we're showing that this is 3
Positive x-axis. So that's
plus 4 squared. This is 4.
Obviously this, and that becomes
This is 2. 3.5
into
degrees.
10 raised to 5.
Guess that's it for that one.
54
Net equals
newtons
0.
at 43.5.
Oh no.
Into 10 raised to 5
This
-6.
is 1.5.
These are Gaussian surface.
These are all feet.
Together.
And the so far this section seems to be 400 times
And
the
then for point C back here, what is different? It's harder to visualize.
We're showing that this is 30 degrees. We've also shown that this down here
This is
45
we're
degrees.
to have units on this.
But
I would rather the hypotenuse is 2 feet and the angle is 20. So I'm going to green
the magnitude and direction of the result
this,
well,
and I'm going to indicate that this is
in the x direction
2 cosine 20.
100 cosine 30 plus 800 cosine
And
45.
this is 2 sine 20.
Resultant in the y direction
is going to be
200
cosine 4. All right, so the distance from A to B
minus 800
or U 45 AB
The
is going to be in the x direction is going 1.5 feet
squared
Now,
400
sine
theta.
in the y direction.
And
It's going to
the angle is going to be
negative
the inverse tangent negative
from 2 to 3, so it's only negative 1 foot.
with y over
At
frx.
this point.
So let's put all of these into a
And the
calculator.
z
So
direction
we're
is
gonna do
going
the first
down
two
4
so
feet.
that you know exactly where that theta is, whether it's
point
here,
downward,
upward,
U,
horizontal.
AC.
And so, negative 3.1 going to a calculator, 356
is from A to C.
400
A to C.
cosine 30.
Well, in the x direction is going backwards, so negative 2 sine 20.
Cosine newtons. Okay, next one. 400 sine 30 minus 800
In the
y
direction.
Front.
It's going over
266 newtons.
Plus
Go through exactly what
2
I did.
cosine 20.
Square root from
So
B.
that would be
The first one, it's going
positive direction.
Point charge to we
Third.
can say that the
Cosine
electric field equals k
squared
30
plus over. Okay, second one, it's only going
now what about
negative 2.
And then in the z direction, it's just
Squared
negative
is 980. It's going negative 2 in the
Okay,
x
so
direction.
All right.
let's find the electric field.
And
It's going
theta
right at this green spot,
is
we are
the
on
inverse
inside
tangent.
This inner shell. There is no charge here. If there is no charge, then Q
negative
is
6.
0.
We need to figure out the resultant force.
So,
Force AB
sine 30.
So
is going to be FAB
over the x direction, actually.
U vector AB over U.
In a conductor.
No,
AB.
negative. So dA is
F
2.
AB
E must also be
is going to be, let me put this into a calculator.
degrees. So we're supposed to measure clockwise from the positive x-axis, so that would be correct.
FAB, which I did not write down yet, but the book tells us that
in the book,
FAB
983, 21.8. Yeah, it would be positive 20.8 as measured from
is 20 pounds.
clockwise direction, negative 2.
Charge right there. So that there's means no that
So I
the
can take
field
square
can be
root
written as a point
Times
going to be
U vector AB. I'm going to use the x component. Negative 2. Nope.
So here we are
would
given
be
that the
AB,
potential
not BC.
is force F,
times the total
Which is
charge
1.5.
inside, which is
components acting
2Q,
along x, y, and z
divided
axis
by
as
r
shown,
squared.
right?
Over the square
The force
root.
F is 80 Newton
1.5 squared
and alpha
plus
is
1
60 degrees.
squared
And let's
plus
see
4
now.
squared.
C less
Gamma
than
Put
R
it
is
in here.
55 degrees, right? So based on this, you have to calculate the magnitude of its component. So clearly fx component will be equal to f cos alpha
outer region.
Minus
Okay.
156j,
This is
and the third one is
I
square
know
root.
C
Okay.
must be equal
equal
to
to
0.
That gives me
cos of
6
let's see if that-
point
which is equal to 40 Newton.
8
Next,
4
we move
question
on to
is
the
5
second component
Q
fy.
here. So I need
That is equal to if cos z component
Minus
because
two.
sin
Minus
theta is not
-52,
here.
-150. I'll put -1 into the numerator. So my error
Gamma
was in
give us
-5
degrees. And this is 56.6 Newton, right? Now to calculate fy, what you can do is f will be equal to root over of fx squared plus fy squared plus fz squared, right?
the conductor.
4.556j.
That will be equal to root over
I'll
of
put
fx is
-4 in the numerator.
Minus 4q plus 2q is minus
fy
2q.
is, you have to
So
calculate
q
that
plus
plus
minus
fz is
18 point
56.6
And we get
squared,
E
right?
equals
2k.
1
Y
Using
will
the
be
edge of the
equal
plate
to
with the y
F
F.
40 Newton, right?
times
Is what we
minus
have.
18.
So you have got all these components. I hope this is clear to you, and I'm
Where
very sure
AC
that thank you.
point this. So now the denominator becomes, well, first of all,
belongs together.
right?
FAC. So far, this section seems to be exactly the same as the previous 40 pounds.
So
I don't know. So it's 40 times. Seriously.
0 there.
So now in the denominator,
this is
30 degrees. I'm putting. We're also shown that this down here
2, okay.
is 45 degrees. -2 sine, rather mark this as 45 degrees, and it would be 45 degrees because in all of us, I don't understand right angle. 2 plus 2 cosine, the magnitude and direction of the resultant force. Well,
66 is so much easier.
square. I already have force resultant in the x direction is going to be 400. So cosine 30 is 800 cosine 45. -2 sine 20. Force resultant in the y direction is going to be 0.87. 400 sine. Now I'm going to put the 2 plus 30 minus 800 sine 2 cosine 20 in the numerator. Beta. The resultant force is going to be the square root of FRX squared plus F y squared 27. And the angle is going to be the inverse tangent of and gamma, and now negative over all of these into a calculator. It's important that you do the first two so that you know exactly where that theta is, whether it's going downwards or upwards. And so go into a calculator minus 4.87. 400 cosine 30 plus 1.975 912 minus 4 Newtons over. Okay, next one. 400 sine 30 minus 300 sine 45. So
we can say that the electric field
negative 316.2 40 times 28.5.
You can also write it in terms of
square root times the first one. Now in the denominator, and we're still not done. Square plus second one.
This is when you're field must also
Squared is 980 using this equation Newtons. And theta, I'm putting the inverse tangent, that in the calculator. I need to put of the second one, or the y direction.
Must also be 0 has to be out there.
Over the x direction. Negative 20 newtons to 21.8 degrees. So we're supposed to measure clockwise from the positive x-axis, so that would be correct. Acting at point. So those two are my answers. Let's check if that's the correct answer.
Inside
983. So yes, it is 21.8. Yeah, it would be positive 20.8 as measured alpha, beta, and gamma. We just use the inverse cosine. We add these together.
Let's see now.
Of FR x, which is 1.97, over FR, which is 52.
Okay, for this problem, we have a plate that has 4 different forces acting on it. Force 1, force 2, force 3, force 4, and it actually gives us the magnitudes and angles for each of these. It actually doesn't give us the actual angles, but it tells us that force 1 and force 2 form 3, 4, 5 triangles with the x and y axis. Right, so using these, we have to actually find the resultant force vector and show that the resultant force is 0. So we can do this by determining the x and y components and summing each of them individually to see that they both add up to 0. So let's start with the horizontal component. Because we have all the magnitudes and we can determine the component space of this 3.5 triangles, we can each of these triangles individually. So this one right here is the triangle that the F force 1 forms with the y and x axis, and this triangle is the one force 2 forms with the x and y axis. So we'll start with force 1. So for the horizontal component, we're going to be looking at, we're going to be using right angle trig, so SOHCAHTOA, right, to determine what the purely horizontal component is. So here, because we need to find the horizontal side, or horizontal component, we use cosine in SOHCAHTOA, which is adjacent over hypotenuse. So here it's going to be 8, this is blue, it's going to be 8 kilometers times 4 over 5, moving on to force 2, plus, and here it's going to be SOHCAHTOA once again, but it's going to be 3 over 5. So it's going to be 6 kilonewtons, so that's magnitude of F2, times 3 over 5. And we can just add, sorry, we can actually just subtract force 3 and force 4. Because if you look in the diagram, both of them are going in the opposite direction horizontally as F1 and F2 are. So here we go. And if we do this math really quickly, we'll actually see that this actually all adds up to 0. So we know that our horizontal component comes out to 0. Next, for our vertical components, right, so let's get force 1, 8 kilonewtons times 2 cosine 4 triangle. We need to find our vertical component using sine, right, and sine is opposite of our hypotenuse, so it's actually going to be 3 or 8 times 3 over 5. And since this force is heading down, I'm actually going to add a negative in front of it. Next, we have to add our vertical component of force 2. Once again, we look at this triangle, and we need vertical component, right? So we do sine, and opposite over hypotenuse here is also, or is 4 over 5. 6 times 4 over 5. And once again, in our diagram, we actually see that there's no vertical component to F3 or F4, right? They're just horizontal lines pointing towards the left. So let's stop here and check if these add up to 0. Lo and behold, they do. So we know that both of these resultant components add up to 0, so we know our resultant force is 0. F,
It's
R equals 0,
negative
right?
26.
Negative
Negative 4. At least this diagram is easier to see. We need
step solution.
So
Let's
you're
solve
looking at
today's
this
problems
one right
together.
here.
Tau x, y.
Resultant. Let me go ahead and draw a diagram. I can draw here. 6.8.
That's the only way.
4 minus 4.87. We've got 1.97. Okay. 27.6 minus. We've got a letter B down here. Remember, I got an easy one. 3.
Welcome to EDU.
Is going to be 0.
When you have a point charge, that the
minus 450 as well. Y. This and we know that the length plus me. And then the first thing that I want to do is I want to find the direct force to solve that into a calculator. It's harder. Which is just going to be the force. It's going negative.
First region, radius less than A. Okay? We are right here in this little green dot. We have no charge there. With no charge, Q is 0.
Minus.
So E must be 0. Okay, A less than
visualize here. The resultant force is going to be inverse. So divided by the magnitude is 250 So I'm going to got two equations. And it's going so let's go ahead and get that.
Now we can just
put all of these into a calculator. So the first two component is just going to be where theta is, whether it's downward or upward. I'm going to indicate
times Q. Total charge
substituting that into the first equation.
Over
I
R
get
squared.
700.
There it is.
Cosine 30 plus.
All right, now we're in our outer shell.
F sub F is calculator 1 going to be 2 cosine theta.
What is
let's check if that's F2 has a little point where so 700 gives me an angle down. Cosine 435 direction. Negative. Now I'm going to put negative 250 in the numerator. 30. This distance here. Negative 3. Tangent of theta. Negative 0 x component. Yeah, is going to be the x direction is going to 1 negative 1. Y is 120.
That means that Q.
Yeah, they're all directly given. Here's the y direction. So let's simplify it a little more. 3K. New calculator right now. Negative 2 to 3, so it's only negative 1 theta. going down alpha
by
y.
definition.
And gamma, I change the numerator to negative 6.6.
We're going to write down Gauss's law.
And gamma.
So which says,
let's go back to BA. B to negative xy, which would just be the xy and z coordinate. In the numerator. Those are correct. Except AC about whether or not negative 97 negative 48. Well, it's going to be now is going negative. We've got in the x 3 gamma. Negative 2 4 0 together. Angles for half here. These in the calculator. There and so that's E. And I'm not going to draw the. All right, it's going to be 0.5. Hey, now what are the units here? E direction is just negative. The result is just going to be the 5.5 and force going AB, and then negative 5.0. Okay, BA, where root 350. We need all three forces in Cartesian. Oh, wait a minute. 5.06.
Welcome to
Where 3.61 going to be 6.51. So the only difference is that the book writes it as positive. X is redirection. I guess they're showing x on B in the opposite direction of the x-axis. And so, okay, that makes sense. Oh, wait a minute. Very good. We're done. Check the answer. It's going to be negative 5 is right here. Yep, x component, negative, and y component. So I'm just going to go to the multiply that out.
Come to the channel here with X complex questions and break them down into simple step-by-step solutions that solve these problems together.
Okay, so let's determine the change the other side of the horizontal 30 degree, and the angle between the chain theta and the horizontal axis is 60 degrees. Now let's calculate the horizontal and vertical component of the chain AB. Horizontal AX equal to A times 4 equal to 3 times cos of 30 degrees. That's 150 times 3. Similarly, we have vertical component as 3 times 30 degrees, equal to 600 times sine of 30 degrees, that is 150 newtons. Now for chain series, the horizontal component is FC equal to FC times cos of 60 degrees, that is 250 times cos of 60 degrees, which is equal to 5 degrees. Similarly, we have vertical component FCY equal to 125 times square root of 3 newtons.
Front KQ, and it's going to be a little stupid.
So we're looking for some components, and this is
150 times square root of 3 squared, 150 Newton, and for CD in Cartesian vector form equal to 1.55 plus 125 times root 3 J Newton.
So
which is not strangely enough, the x direction is 30.
Well, it's just
500 pounds.
It has to be 0.
And you have the x and y directions like this. This is the y direction, and this is the
Welcome
x
to the
direction.
channel. Here we tax complex questions and break them down into
45
simple
degrees.
step-by-step solution. Let's solve today's
Which, by
problem
the way,
together.
would make this 45 degrees.
At least this diagram seems easier.
And then we have F2, C, the Pythagorean theorem. So I'm going to type in this way because I like to draw them tail to tail squared.
It is a conductor. So, for the region between
It's a little bit harder to interpret, though. Let me go ahead and draw just what I can draw here. Considering where 30 direction is, okay, 4.5 square, and that's going to be 1 square. 400 cosine of alpha 1. Okay, 2. So, let's get the last one. Continue this through. We've got a point B down here, which looks like the x. Okay, so
point charge
components.
And we get our electric field, E. We have the inner.
Let's see here. Easy one. S1. Definitely the easy one. There's a point A to be up here. 200. 43 degrees. This is 3. 45 degrees. This is 4. And that becomes this 42. 3.5 degrees. Guess that's it for that one. 54 newtons at 43.5. Oh no. And the same thing is 1.5.
And we have
these are all feet.
Together.
And so far this section seems to be 400 times point C back here. What is different? It seems harder to visualize. We're showing that this x direction is going to be the cosine of 30 degrees, and the cosine of 30 degrees is the square root of 3 over 2. So this is just going to be 150, negative 100. We've also shown that this down here is 45 degrees. But hypotenuse is 2 feet, and the angle is 20. So I'm going to, green, the magnitude and direction of the well, and I'm going to indicate that this is in the x direction. 2 cosines just go 200. 130 plus root 800 cosine, and this is 2 sines resultant, and the y direction is going to be alright, so the distance from A to B 2 is going to be, or u negative 75 3 I, the result is going to be, in the x direction is going 1.5 feet squared plus 500 sine theta, in the y direction is going to be negative, is going to be the inverse tangent from 2 to 3, so it's only negative 1 foot.
Problem we're given pre-forces F1, F2, and F3, and we're asked to find the magnitude.
Put all of these into a calculator. Direction is going down forth, that you know exactly where that theta is, whether it's downward, AC. So negative 3, 1 going to a calculator is from A to C. 400 cosine 30. The x direction is going backwards, so negative 900 2 sine 20.
This angle right here is 10 degrees, and this angle right here is 60 degrees. So in total,
400 sine 30 minus 800 in the direction. It's going over 266.
Force 2 of 200 newtons And that's just
plus
Go through exactly what
2 cosine 20.
Square root from
So that would be
the first one. It's going
positive direction.
We can say that the
Negative
field equals
the
Square
x-axis
plus
is some
over second one.
So we're going to go ahead and just sum all of our x or
And then in the z direction, it's
Square
negative
is 980. It's going 3. -2 in the x direction.
100 times cosine
And theta
100 degrees because
is
cosine
the
in this
inverse
case
tangent.
corresponds to
there is no
the
charge
x
here.
or horizontal
If there is no
components.
charge,
For F2, we actually don't even
we need to figure out the resultant force. So,
for F3,
force AB.
This force is
going to be FAB
the opposite direction.
Over the
Force
x
reversed.
everything actually.
U vector
Instead of
AB
using cosine, because
over
we have a
U.
5, 12, 13 triangle, we can
No.
also
AB.
Negative.
SOHCAHTOA
AB
cosine
is going to be, let me put this into a calculator.
12 over 13.
So we're supposed to measure
This right here,
clockwise from the positive x-axis. That would be
FAB, which I did not write down yet, but the book tells us that
in the book.
FAB 983
that to 150.
21.8. Yeah, it would be positive 20.8 as measured from. It's 20 pounds.
For y, for the vertical, force 1.
And so I can take square
Very
root.
similar, except we use
Times
sine.
Going to be
U vector AB. I'm going to use the x component. Negative 2.
So here we are
Would
given
be
that
AB, not BC.
force F
It's just 1.5
components acting along
Positive
x, y, and z
180
axis
times
are shown,
this
right?
time it's sine,
over the square root.
or opposite over hypotenuse.
1.5
So 180
square.
times 5 over
And
13.
alpha
Plus
is
1
60 degrees.
square.
And let's
Plus
see
4
now.
square.
Gamma
Put it
is
in here.
45
This
degrees,
will come
right?
out to be
So based on this, you have to calculate the magnitude of its component. So clearly, fx component will be equal to f
this will
cos
come out to be
alpha.
Outer region.
minus
One.
156J.
This is
And the third one is square root.
Okay.
Must be equal
Equal
to
to
That gives me
cos of,
Okay, let's see if that
6.8
and
which is equal to
sum the
40
squares and take the square root
Newton.
of it.
Eight.
Next,
Four.
we move on
Question
to
95.
positive y.
here. So I need
That is equal to
And I got a total
f
magnitude
cos, sorry, z component because
Minus
the
Minus
theta is
negative
not here.
52, negative 150.
Now I'll put negative 1 into the numerator.
So my error
Gamma.
was in 200.
Give us negative
5.
degrees.
with the positive x prime
And this
axis.
is 56.6
So to do that,
Newton, right?
we
Now to
can
calculate
use
Fy,
this
what you can do
pretty
is
simple.
F will be equal to root over of
property.
fx
So
squared
beta is going
plus
to equal
fy squared plus fz squared, right?
oops,
This is
arctan
4.56J.
That
y
will be
component
equal
over
to
x
root over
Now I'll
of
put
fx is
negative 4 in the
Put it on
numerator.
minus 4q plus 2q is minus
Fy
2q.
is
calculator
fy
once
again.
plus z is
18.2
And we get
squared,
E
right?
equals
K.
Y will
Using
be
the edge of the
equal
plate
to
with the y-axis.
now
F
40 Newton, right?
times
Is what we
minus
have.
18.
So you have got all these components.
15.75.
I hope this is clear to you and I will
AC. Point this. So now the denominator become
71 degrees. But
Well,
remember,
first of
this
all,
angle is actually the angle
FAC.
between
So far, this section seems to be exactly the same as the previous 40 pounds. I don't know. So it's 40 times. Seriously.
Theta here, or sorry, the angle between the x
So on the
axis.
denominator, this is 30 degrees.
Force 1
I'm
is 10 degrees.
putting. We're also shown that this
20
down
degrees, and
here
this one forms with the
is
positive
45
x-axis.
degrees.
But
Negative 2 sine would rather mark this as 45 degrees, and it would be 45 degrees because in all of it's right angle. 2 plus 2 cosine. Magnitude and direction of the resultant force. Well, where?
I already have
Force resultant x direction is going to be 400.
X prime axis.
So, cosine 30 numerator is 800 cosine 45. 2 sine 20. Force resultant in the y direction is going to be 0.87. 400 sine. Now I'm going to put the 2 plus 30 minus 800 sine. 2 cosine 20 in the numerator. Beta, the resultant force is going to be the square root of FRX squared plus FR I squared 27. And the angle is going to be the inverse tangent of and gamma. And now negative over Now we have to put all of these into the calculator. It's important that you do the first two so that you know exactly where that theta is, whether it's going downward or up. And so go into a calculator. Minus 4.87. 400 cosine 30 plus 1.975. 912.27.6 minus 4.6. Okay, next one. 400 sine.
Similarly, the surface charge density on the outer surface
30 minus 300 sine 45. So
we can say that the electric field
negative 316.2 40 times 28.5.
So you can also write it in terms of
square root times the first one now in the denominator, and we're still not done. Squared plus second one.
This is when you consider Q is 0, field must also
squared is 980 using this equation newtons. And theta times the inverse tangent that inverse calculator. I need to put of the second one or the y direction.
must also be 0 has to be out there.
Over the extra sine 52.1 negative 20 newtons to 21.8 of 9 degrees. So we're supposed to measure clockwise from the positive x-axis, so that would be correct. Acting at point. So those two are my answers. Let's check if that's the correct answer. 983. So yes, it is. 21.8. Yeah, it would be positive 20.8 as measured alpha, beta, and gamma. We just use the inverse cosine. We add these together of FR X, which is 1.97, over FR, which is 52.
Okay, for this problem, we have a plate that has 4 different forces acting on it. Force 1, Force 2, Force 4, and that actually gives us the magnitudes and angles for each of these. Actually, it doesn't give us the actual angles, but it tells us that Force 1 and Force 2 form 3, 4, 5 triangles with the x and y axis. Right, so using these, we have to actually find the resultant force vector and show that the resultant force is 0. So we can do this by determining the x and y components and summing each of them individually to see that they both add up to 0.
Just have to change
so let's start with the horizontal 23. Because we have all the magnitudes and we can determine we can change things in these 3, 4, 5 triangles.
46.7.
Each of these triangles individually. So this one right here is the triangle that the F force 1 forms with the y and x axis. And this triangle is the one force 2 forms with the x and y axis. So we'll start with force 1. So for the horizontal component, we're going to be looking at, we're going to be using right angle trig, so SOHCAHTOA, right, to determine what the purely horizontal component is. So here, because we need to find the horizontal side or horizontal component, we use cosine in SOHCAHTOA, which is adjacent over hypotenuse. So here it's going to be 8, this is blue, it's going to be 8 kilometers times 4 over 5, moving on to force 2, plus, and here it's going to be SOHCAHTOA once again, but it will be 3 over 5. So you be 6 kilonewtons. So that's magnitude F2 times 3 over 5. And we can just add, sorry, we can actually just subtract force 3 and force 4. Because if you look in the diagram, both of them are going in the opposite direction horizontally as F1 and F2 are. So here we go. And if we do this math really quickly, we'll actually see that this actually all adds up to 0. So we know that our horizontal component comes out to 0. Next for our vertical components. Right, so let's get force 1. 8 kilonewtons times 2 cosine 4 triangle. We need to find our vertical component using sine. Right, and sine is opposite of our hypotenuse, so it's actually going to be 3 or 8 times 3 over 5. And since this force is heading down, I'm actually going to add a negative in front of it. Next, we have to add our vertical component of force 2. And so that we get this triangle, and we need vertical component, right? So we do sine, and opposite over hypotenuse here is also, or is 4 over 5. 6 times 4 over 5. And once again, in our diagram, we actually see that there's no vertical component to F3 or F4, right? They're just horizontal lines pointing towards the left. So we can stop here and check if these add up to 0. Lo and behold, they do. So we know that both of these resultant components add up to 0, so we know our resultant force is 0. F are equals 0, right?
26 These diagram easier to see.
Music, and these are the answers.
Step solution. That's all today.
Welcome to EDU World Space.
Hi, this problem we have to solve problem 10.7 using Mohr circle to find the equivalent in-plane strength at
this problem together.
Let me go ahead and draw a diagram. I can draw here. 6.84 minus 4.87.
And the radius of the circle, which I have already done that.
179.7 27.6 minus got a B down here. Remember, I got an easy one. 3.
At this point.
Welcome to EDU.
Which I will call this point A, and that's our original plane.
Rather
60-degree counterclockwise from the
is going to be 0.
When you have a point charge, the
electric
this will be
as well. Why?
This
is 1.5. And we know that the length is plus me.
F2.
And we're given the magnitude and direction of all of these
So the first thing that I want to do is I want to find the direct force and solve that into a calculator. We see that it's hard.
And using those numbers, we can actually calculate our resultant vector numbers.
Which is just going to be the force.
Well, it's going negative.
First region, radius less than a.
So we know that it forms a 75
Okay.
degree angle with the x-axis.
We are right here in this little green dot.
So for F1, you can use sine and cosine. You can know that it forms 4 times.
We have no charge there. With no charge, Q is 0.
Minus.
So E
Plus is
must be
actually
0.
-4 because it's going in the
Okay,
opposite
A
direction.
less than
Visualize here. You have to figure out the resultant force is going to be the square root of that. So, divided by the magnitude is 250 So, I'm going to
kilonewtons. Because it forms a 30 degree angle with the y-axis, it must form a 60 degree angle with the x-axis. So,
we got two equations. So, let's go ahead and get that.
Now we can just
Put all of these into a calculator. So, the first two component is to know exactly where theta is, whether it's downward, upward. I'm going to indicate
Q. Total charge
substituting that into the first equation.
summing up
Over
all of our
700
There it is.
cosine
horizontal
30
components individually.
plus.
All right, now we're in our outer shell.
F
C
sub
less
F
than
is calculator 1 going to be 2
somewhere in here.
cosine theta.
What is
Where
let's
check if that's F2 has a point where so 700 gives me an
which is
464
116
kilonewtons.
Sine 435 direction. Negative. Now I'm going to put negative 250 in the numerator. 30. This distance here is negative 3. Tangent of theta. Negative 0 square root is going to be, I guess the x direction is going to be negative 20. Y is negative 20.
That means that Q
starting right. So in this
Y direction. So 3. Let's get it simplified a little more. 3K. Calculator right now. Divided by 2 to 3, so it's only
10 raised to power negative 6, right, and the strain that is acting in the z direction is 0 because there is no strain that is acting in the
direction is going down. Gamma, I change the numerator to negative 0. Distance. And gamma. Let's go back to BA. With B to A is y, which would just be the x, y, and z coordinate. The numerator, those are except for z. About whether negative 97.
Y and x components, so we can plug those in.
Right, and when you calculate it, you get this equal to plus the share strain divided by 2 whole square. You have the values, you just
degrees.
9 times. Now, it's going negative. We've got in the x.
Yep, so our force forms an 11.08
to
kilonewton
1. into 10 raised to power
Three
negative
gamma.
Negative 2 times 5.40 together.
What is difference here? These in the calculator. So, and this is 5 degrees. We're also shown that this down here
this is
Z is
positive
going to be 5 degrees. Okay, now what are we writing here? Z direction is just negative. The result is just going to be the 5 magnitude direction. Is going 0.61. And force is going negative 5.37. Okay, it's going to be 400 sine 30 minus 800 sine
into 10 raised to power
45.
negative 6. Right, so now that we have the value,
the resultant force is going to be the square root of FRX squared plus a square root. We need all three forces in Cartesian.
Welcome to
Square 3.61 going to be 6.51.
So the only difference is that the book writes it put all of these into the calculator.
And so, I guess they're showing X calculated in the opposite direction of the X axis. And so, okay, that makes sense. Wait a minute. Very good. Answer is going to be negative 5. Is right here. Yep, X component is negative Y component. So, multiply that out.
To the channel, here we tax complex questions and break them down into simple step-by-step solutions that solve these problems together.
Okay, so let's determine the change with respect to the horizontal axis. 30 degrees, and the angle between the chain zero and the horizontal axis is 60 degrees. Now let's calculate the horizontal and vertical component of the force. AX equal to 8 150 times 3. Similarly, we have vertical component as 3 times 30 degrees equal to 6 times sine of 30 degrees, that is 150 newtons. Now for chain series, the horizontal component is F squared.
7 into 10 raised to power minus
SC times cos of 60 degrees, that is 250 times CY equal to 125 times square root of 3 newton.
50 times 4 could have been 42 of my answers. Let's check in the book.
Cartesian factor form
We're looking for some
equal to 150 times square root of 3 150 Newton, and for CD in Cartesian vector form equal to 125
really a continuation, although this is simpler than 60 over this way. I do have my the X direction is 30. Vectors, 500 pounds, and you have the X and Y direction is going to be in the I direction. This is J direction.
Here we tax complex questions and break them down into simple step-by-step solution that solve today's problem together.
I need to express each as a Cartesian vector. At least this time, and then we have F2. The Pythagorean theorem. So I'm going to type in the square rate because I like to draw them tail to tail squared.
It is a conductor.
Maybe
So in this
easier said
question,
than done.
For the
radius is
region
equal to
between
It's a little bit harder to interpret, though. Let me go ahead and draw. I'd also like to get rid of this. This is what I can draw here. Considering where 30 direction is, this is 4.5 square, and that's so F1. Okay, 2. So continue this through. We've got a point amounts to. That's 53.2 down here. Looks like the east. Okay, so did that one. Components. Sine 40 at the end.
There is no normal strain, right?
Let's see here. Easy one. F1. Definitely an easy one. There's a point A to be up here. Sine 230.
This is all clear.
It's just going to be 40.
Let's write the
43 degrees. This sine F1 degrees. This is 4 over 2. And that this is 2.5. 53. Guess that's it for that one. 54 newtons. I at 43.5. Oh no. And the same thing is the positive x direction.
Along the y
And we
direction.
have
In the j direction. And so far this section is 400 times better. There's a point C though here. What is different? It's harder to visualize. So this x direction is going to be the cosine 4.5j degrees, and the cosine of 30 degrees is the square root of 3 over 2. So this is just going to be, and then it's going to the positive k direction, negative 150. It's also shown that this down here, f sub 2 is just going to be 130. But hypotenuse is 2 sides, and the angle is 20. So I'm going to, green, the magnitude and direction of the result as well. And I'm going to indicate that this is in the x direction. 130 plus root 800 cosine, and this is 2 sine resultant, and the y direction is going to be alright, so the distance from A to B 2 is going to, for u, negative 75 degrees I, the result is going to be, in the x direction is going 1.5 feet squared, 400 f in the y direction, and it's going negative, the inverse tangent, from 2 to 3, so it's only minus 1 foot. Y over
F1, F2, and F4 is 180.
Let's put all of these into a calculator. Z direction is going down 4 feet. You know exactly where that theta is, whether it's going downward,
I'm going to go ahead and just
AC. So, negative 3, 1, going to a calculator, is from A to C, 400 C. Where the x direction is going backwards, so it's negative 2 sine 20.
F2 you actually don't even have this angle right here is 10 degrees. Directly on this angle right here is 60 degrees. F3, however, in total,
400 sine 30.
This force is going in the other direction, 1 degree the opposite
In
direction.
the direction. It's going over 266.
Because they have force 200 newtons, we can just use inverse trigonometry.
Plus, go through 2 cosine 20 square root. So that would be the first one.
That is equal to
This right here,
Go
5
positive direction.
So we can say that the electric field equals
Yeah,
Square.
x-axis.
Second one.
So we're going to go ahead and just sum all of our x, or
And then in the z direction is
horizontal
negative 900.
5 newtons for the horizontal component. Now, for y, for the vertical, force 1, very similar, except we use sine of 20 degrees.
80 is going 3.
This time we actually use 2 times cosine
And theta
20 degrees because once
is the inverse tangent.
Find the x or horizontal component. For F2, we actually don't
We need to figure out the resultant force. So, force
times 5
AB.
this force is
going to be FAB over
and this will come out to be
right, and the shear strain is equal to 650
everything actually. U vector AB
using cosine
over U.
5, 12, 13 triangle.
AB
right.
These
Now
will
what we're
square
going to
both.
do over here is that we are going to use
Using cosine
is going to be, let me put this into a calculate degrees. So we're supposed to measure
this right here.
clockwise from the positive back here. That would be FAB, which I did not write down yet, but the book tells us that FAB 983 21.8. Yeah, it would be positive.
to be able to build a circle, we need the axis, right? So to do so, we are
to do
going
that,
to use the
we
equation
can use this
10.13,
pretty simple
right? So as per that equation, the absolute
20.8 as measured from is 20 pounds.
for y, for the vertical, tan, force 1.
And so I can take square
Very
root
similar, except y
times U vector AB.
And
I'm going to use the x component.
So here we are
AB, not CC. It's just 1.5
components acting along
Positive
x,
of
y, and z
this time it's
over the square root.
opposite of our hypotenuse.
1.5 squared.
the
Of 72.
difference of the strains
Plus 1 squared.
Remember,
Plus
this
4
angle is actually
squared.
Gamma
the
is
result
the
vector in the x-axis.
So based on this, you have to calculate the magnitude of each component. So clearly, if x component will be equal to f cos
Beta here, or sorry, the angle between x y axis and force 1 is 10 degrees.
Okay.
So if you add that 20 degrees and you know f of y
That gives me
x-axis,
into 10 raised to
then
power negative
you know we have to subtract 30
right now, all
degrees
we need to do
from
is
this
that we need to
longitude, giving us
Okay, let's see if that
circle,
which is equal to 42
anglers until it's
Newton.
derivative.
Next,
4.
question
is
is
5.
positive y.
Circle those really quick.
that,
So our resultant force
the
vector
given state of the trains
has a magnitude of 389.44 newtons and a form of
So
42.71
That is equal
to an
to
angle I got positive
positive
magnitude.
cos, sorry, z component because
Negative
theta is not here.
52, negative
In this problem, I just draw the three-body diagram.
Gamma.
Now, here let theta is the angle made by the force F with the horizontal in the anti-clockwise direction and FR is the resultant force.
So to do that,
And phi is the inclination of resultant force with positive x-axis in the counterclockwise direction and alpha is the angle made by the resultant force with negative x-axis. Now I will apply the law of cosine to the vector triangle and the expression for OA square is equal to AB square plus OB square minus 2 multiplication AB multiplication OB cos angle ABO, or you can write the next expression as or OA is equal to under root AB square plus OB square minus 2AB multiplication OB multiplication cos angle ABO. Finally, you can write the value of FR as under root 450 square plus 700 square minus 2 multiplication 450 multiplication 700 multiplication cos 45 degrees. So you will get the value of FR as 497 Newton.
FAC. So far, this section seems to be exactly the same as the previous section.
So I can write
Don't know. So it's 40 times. Seriously.
sine angle
expression that makes gamma
AB
angle between the
is
So
equal
on the
to
denominator,
AB
30
by
degrees.
sine
We've
angle
also shown that this down here
or
is 45
FR by
simply just
or FR by sine angle
right, and we'll have
ABO
negative 2 sine
sine
this
angle
5 degrees square, and it would be 45 degrees because it's all right angle. 2 plus 2 cos the magnitude and direction of the resultant force. Well,
sine 45 degree is equal
force
to
comes from result
50 by sine
x direction
15
is
degree plus
going to be
alpha
400.
15 degree plus alpha is equal to
So
sine inverse
30
450 by
100
497 multiplication sine 45 degree.
2 sine 20.
So finally you can write the
in the
value
y
of alpha
direction
as
is going to be
39.81 degree minus
400 sine.
15
I'm going
degree,
to put the
which is
230
approximately equal
minus
to
800 sine.
25 degree. Phi angle is equal to 180 degree minus alpha, which is equal to 180 degree minus 25 degree. So you will get this value as 155 degree.
Force is going to
The
be the square
inclination of
root
resultant
of
force with positive
FR
x-axis in
squared
counterclockwise direction is 155 degree.
I squared 27, and the angle is question 47. Oh,
So in this
it's the
example, we
same
have an
question.
shell of positive 2q charge and an outer shell of minus
Tangent
2 charge.
So this time now we're told that f sub b is 600 newtons in the calculator, and theta is 20 degrees. This is the same question, but actually easier. That theta is, whether it's kind of like we're working forwards on this one.
9 times 10 to the 9.
Go into a calculator.
Minus electric field. Alright, so
4.87, given basically everything we need to know. 1.975, 912.7.6 minus magnitude and direction of the result. So F newtons are next one going to be 700 sine 30 minus 600 30 minus 300. That's at 20 degrees. It is 20 degrees. Cosine 20.
B less than R less than C.
Negative 300 together 700 cosine 30 plus 600 the first one sine 20 600. We're still not done. Yep. Squared plus second one FR is the square root of FR squared is 980 this equation. So let's just put those into the calculator.
There we go.
And theta in parentheses 700 sine 30 minus 600 cosine 20. The second one, or the y direction, in parentheses 700 cosine 30 over the x direction 600 sine 20.
So I need minus
and
2q
square it.
on this inner surface.
839 negative 22. Now this is question 47, and that is the correct answer. Continuation of the inverse tangent. So we're supposed to measure clockwise from the positive x-axis, so that would be correct. Of the y value
We get E equals
over the x value.
4 pi epsilon
Put that in a calculator.
times minus 2q.
So those two are my answers. Let's check if that's the correct answer.
Inside
983. Yes, it is. 21.8. Yeah, it would be positive 20.8 as measured alpha, beta, and gamma. We just use the inverse cosine from the other equation of FRX, which is 1.97. See how am I measuring this? Counterclockwise from the positive y
we have a plate that has 4 different forces acting on it. Force 1, force 2, force 4, and it actually gives magnitudes and angles for each of
Let me
these.
think about what's going on here.
Function. You can get out your graphing calculator
FRX
and
is negative 213.
It doesn't give us the actual angle, but it tells us that force 1 and force 2
They cancel each
form
other
3,
out.
4, 5 triangles with x and y axis.
And in K,
Right, so using these, we have to actually find the resultant force vector and show that the resultant force is
So I'm
It's 811.
and I think that all of you
0. So we can do this by determining the x and y components and summing each of them individually to see that they both add up to 0.
You just have to change the
So let's start with the horizontal
23. So the resultant would be here. So the theta that I measured is this. That I calculated is that.
all the magnitudes,
And that theta was 75 degrees to negative 46.7. It's going to be the square root of
these triangles
that 75 degrees. So if we're going to measure it counterclockwise from the positive y-axis, then that's going to make it there. So that's just going to be
force 2 forms with x and y axis.
15 degrees.
So we'll say force 1. So for the horizontal,
And that is correct.
Okay, so now we can look at the charges that are around these shells.
component, we're going to be looking at, we're going to use a right angle trig, so SOHCAHTOA, right, to determine
the result's going to be
purely horizontal
here.
component is. So here, because
15 degrees.
we need to find
Inside of this, guys, we are
the horizontal side or horizontal component, we use cosine in SOHCAHTOA, which is adjacent over hypotenuse. So here it's going to be 8.
So, I'm going to begin
okay.
by rolling this guy.
And on to force 2 plus, and here it's going to be SOHCAHTOA once again, but it'll be 3 over 5. So it'll be 6 kilonewtons, so that's magnitude F2.
Okay. And then what about on the outer surface? Well, on the outer surface,
That's 3 over 5.
I'm graphing it now.
And we can just add, or sorry, we can actually just subtract force 3 and force 4. Because if you look in the diagram, the number,
No, it doesn't
What has to
really
be out there?
look like it is to me.
Minus 2q. That's
But
the
I
only
don't
way
in the opposite direction horizontally,
Beta
as
and
F1 and F2 are. So here we go.
Obvious.
And if we do this math really quickly, we'll actually see that this actually all adds up to 0.
Alpha's
So
going to be
we
the
know
inverse
that our horizontal
cosine
component
of
comes out to
negative
0.
648
Next for our
over
vertical components.
756.
Right, so
7
let's get force 1.
I'm going to put that
Times 2 cosine 4 triangle. We need to find
direction in the XY plane.
Welcome to EDU World Space.
Okay, so
right angle here.
using sine. Right, and sine is opposite of our hypotenuse, so it's actually going to be 3 or 8 times 3 over 5.
This is 4 minus.
And since this force is heading down, I'm actually going to add a negative in front of it. Next, we
field everywhere, and where the charges are.
And then we got F3.
to add vertical force to it. And so that we get this triangle, and we need vertical components. Right? So we do sine.
Let's go ahead and resolve
times 10 to the
F2 into
9.
its components, because F1
also
is
equal.
just in the
The opposite
negative.
of hypotenuse here is also, of course, 4 over 5. 6 times 4. And once again,
2 in the
Gauss
XY
says that the
plane.
closed loop
we actually see that there's no component to F3 or F4, right? They're just horizontal lines pointing towards the left. So we stop here and check if these add up to 0. And behold, they do. So we know that
9 cosine
E must be
30,
0.
which is F2XY,
Okay, A less than R less than B.
and then that's going to be the
We're in
sine of
this inner
40.
shell, or first, our small
both of
shell.
these resultant components add up to 0, so we know our resultant force is 0.
Y
F
is
R
negative
right?
X,
So now we're in this first voided region.
cosine
Well,
30.
what is the total That was a point charge,
and it's going
and say
positive
the electric
X.
field
In the
E
Z direction,
equals
it's going negative.
1 divided by
The answers.
4
Negative
pi epsilon
F2,
times
and that's
Q,
going to be the sine
total charge inside,
of 30
to
degrees.
Q squared.
All right.
There it is.
F1 only has an X component. I'm going to write it down here.
All right, now we're in our outer shell.
1
C less than R less than D.
X is
C less than R
negative
less than
180.
D. Well, do
That's
I
Step
minus
solution.
2 here. So
That's
here
all
you're
to
looking.
the-
And
What is
then
the total
we need to
charge
add that to
in here?
F3
Well, it must be 0.
so that
Why
the
is that? We're
resultant
inside of a conductor. So
Welcome to
E
EDU
along the
World
positive
Space.
y-axis.
There it is.
All right.
This
That was not
problem
too
we
bad.
have to
So,
Now what happens if we are
F1x
outside of everything?
problem
Plus
So
F2x
now what happens if we
plus
are
F3x
doing a Gaussian surface
would be
outside of
0.
the system? Well, what is the total charge enclosed? Plus 2Q minus 2Q, that equals 0.
Equivalent
E must equal 0 here as well.
at
Now
We can go
F3
to
is
the
J.
What
Now
Appears
X,
to be
Y.
negative.
We go ahead and draw a diagram. Can draw here.
I'm
6.8.
just going to remember
4.7.
Alright, now let's look at where these charges might be located. So,
Okay.
what is the charge
So,
on the inner surface of our smaller
F3
sphere,
I have already done
our
X
smaller shell?
is going to equal
So,
One
if you're looking at
27.6.
charge on the inside, there's something
Of
induced, it must equal 0.
F1x plus F2x.
0. What about
We've got a B down here. We've got an easy one.
F2y.
electric field
Welcome
due
to
to
EDU
flux. Plus 2Q.
So
What about our large shell?
F3y
We go
is
right
going
on
to
this
be
inner diameter, right
600
here.
and that's
minus
our original
So F3Z
Then what about this outer surface? Gotta be 0.
is the
We have a
opposite
net charge of 0 here.
F1 F2Z. So this is going to be. Wish you could see my calculator, but it just slows down my computer way too much to have it be recorded. So I just need to tell you what I'm doing. So I'm going to do F3x, so it's going to be negative parentheses of F1x.
This will be
Where's my F1x?
negative 180 y.
K.
And we know that plus F2.
Okay, so for this problem, we have an inner shell and an outer shell is bound with by the radii A and B. The outer shell.
The first thing that I want to do is I want to find that correct course and solve that equation. See
It's hard. So let's go ahead and look for the electric field.
Okay.
We can actually calculate
The opposite of that plus that, which is just going to be the force. It's going negative y,
Radius
going
which says
600
that the closed
minus
integral we are
F1
here,
y,
this little
which
green
is
dot,
9.
equals the total charge that is
by the way.
enclosed in our region divided
minus
by epsilon to 0.
F2y.
We have no charge there,
F2y.
so charge, this is 0,
F2 minus
so E must be
300,
and this is our area of the
Okay.
this A plus
Visualize here. The resultant force is going to be inverse of F2 divided by the magnitude
that means that Q equals 0, Q equals 0, E
it must form a
equals
60
0.
degree angle with the x-axis.
Okay, F3Z is just going to be the opposite. Got two equations. And it's going upward. So, let's go ahead and get that. Put all of these into a calculator. So, the first two components is negative, so there, negative, positive. So,
By definition,
downward, upward.
I'm
going to
indicate Q.
Third. Substituting that into the first equation,
Summing up
over
all of our
700
there it is.
cosine
horizontal components
30
individually.
plus.
So now we're in our
I
outer
see
shell.
that
So
the
now
F is calculator 1 going to be wait a minute, theta squared plus F1 means F2 has a whole square so 700 gives me an F1 coordinate direction of F3. So now I need the magnitude of
K,
F3.
which is 1 over 4 pi epsilon, or 9
direction. Negative. Now I'm going to put negative 200. Let me put that. 30 is the calculator. 3 tangent negative 0 the x direction is going to 1 negative y is 120.
It just means that Q is
right?
Squared.
And then
So, 3 could have simplified a little more. 3K. Calculator right now. 2 degrees is only
10 raised to power
C
negative 6.
and D.
Right,
So now we are in this outer
Where?
that is acting in
420.
Well, we are in this outer ring.
3.
Remember that the
going down alpha 67. Gamma, I changed the numerator to negative this and gamma. Let's go back to BA. We need a negative xy, which would just be that x and y is 5 in the numerator. Except about whether or not negative 97
Y and x
which is
components.
4Q
Plug those
plus
in.
2Q, 6Q,
and gamma.
Right.
Zero
plus
inverse
D
cosine.
Times
square
6q.
divided by 2 whole square.
6
You have the values, you just
degrees.
need to
Now
Then
is going negative. We've got
in the x.
Yep, so our
First one's going to be
These are all of our origins. Now we can go ahead and graph
8
this.
into 10 raised to
3
5
degrees.
divided by
These in the calculator. We're also showing that this down here
this is
is going to be what are the directions here? The result is just going to be the final Okay, it's going
to be a little steeper. Something like
So
that.
as you can see, we're given the magnitudes
100 sine
of
30
F3
minus
and the resultant
800
force, but not F2.
sine.
Now, what about the
We're also
charge
told that there's a
in our surfaces?
Right,
30
now
degree
that we have
angle
the value,
The resultant
F3
force
and
is
the
going to be the
x-axis
square root
is
of
30 degrees.
frx
Well,
squared
50 degree angle
plus
between
a
F1 and
square
the
root
right?
of we need all three forces in Cartesian.
So in order to solve this type of problem, we have to
Welcome
Welcome to
So the only difference is the book writes it all of these
force one. We're going to write this in I and J vector form.
0.
So we have a vertical component of
I guess they're showing calculator the outgoing to be of the x. And so, okay, that makes sense. Wait a minute, very good. It's going to be negative 5 is right here.
Sine of 75. J. And the reason I
what
subtracted
about for
the
our
first term
large?
or had negative 4 for the first term is because
multiply that
To the channel, here it takes complex fractions and break them down into simple step-by-step solutions that solve the problems together.
some value x, I, plus y,
So we do a
j,
Gaussian
and that's our
surface
job
right
to
here.
figure out. F3 is a little more straightforward.
Okay, so this is to the other side of the
Is that there
F3
must
is
be an
purely along
induced
the positive
negative
x-axis.
2q charge on the
Okay.
inside right here.
And actually, I
So
forgot
it
to
has to be
include
negative
FR,
2q.
our resultant force vector, because we can already figure out
30 degrees.
everything.
And the magnitude change theta and the horizontal axis. 60 degrees. Now let's calculate the horizontal and vertical component of the force. AX
Okay, so let's write this
That's
out.
just the total charge.
equal to Similarly, we have vertical component
To have units on this, we would
Of 75
expect that
degrees
this would be
plus x plus
a bit
6
taller
has to equal
than this.
8
Because
cosine.
this is 6 divided by 4
degrees.
pi. This is
That's
2
okay.
pi.
Right.
But
equal to
x
sine
squared
times
plus
sine of 30 degrees, that is 150 newtons. Now for change CD, the horizontal component is f squared.
10 raised to power minus.
equal to SC times cos of 60 degrees, that is 250 times cos of 60 Cy equal to 125 times square root of 3 Newton.
50 times 4, I could have been 42 on my answers. Let's check.
And
In the book.
Cartesian factor form
We're looking for some
equal to 150 times square root of 3 squared, 150 Newton, and the force seat in Cartesian vector form is equal to 1.55
really a continuation, although this is simpler.
1.5 times
60 over this way. I do have my not the x direction is 30 vectors, 500 pounds, and you have the x and y direction is going to be in the I direction, and the j direction.
Here with x complex questions and break them down into simple step-by-step solution. Let's solve today's problem together.
I need to express each as a Cartesian vector. At least this time. And then we have F2. The Pythagorean theorem. So I'm going to type in square array because I like to draw them tail to tail squared.
The next step is to find the angle with the form
Done.
For the region
do this by
it's a little bit harder to interpret though.
y component over the x component, right? So eventually,
let me go ahead and draw.
I'd also like to get rid of this.
This is what I can draw here. One here. Considering where 30 direction is, 4.5 square, and that's going to be okay. 2. So continue this through. We've got,
and this angle is actually the angle between
point amounts to that's 53.8 down here. Looks like the okay, so did that one. Components. Sine 40 at the end.
There is no normal strain, right?
Let's see here. Easy one. This is definitely an easy one. There's a point A to be up here. Sine 130.
this angle
is just going to be 40.
This angle.
43 degrees. This sine 45 degrees. This is 4 over 2. This is 53. Guess that's it for that one. 54 newtons. I at 43.5. Oh no. And the same thing is positive x direction.
86
In the j direction.
With the y-axis.
And so far this section seems to be 400 times better than point C though here. What is difference is harder to visualize. So in this x direction is going to be the cosine 0.5j degrees, and the cosine of 30 degrees is square root of 3
of the
over
force,
2.
which is directed
This is just going to be,
and
then it's going to be positive
and that axis has
negative 1. This down here
with the y-axis
is 45
with the x-axis.
but hypotenuse is 2 sides, and the angle is 100. So I'm going right to green, the magnitude and direction of the result is and I'm going to indicate that this is x direction. 2 is just 100.
and add them up, so
130 plus
800 newtons. So the final result
800
vector.
cosine, and this is 2 sine result, and the y direction is going to be Alright, so the distance from A to B, 2 is going to be negative 7.5
some value in
I. So it's going to be, in the x direction is going 1.5 x squared.
Here are, because it's just straight upward, there's not even any horizontal
In the y direction is going to be negative the inverse tangent
finally
from 2 to 3, so it's only negative 1 foot.
Problem is it's a 5, 12, 13 triangle, which is a right triangle.
Put all of these into a calculation direction is going down 4 feet. You know exactly where that theta is, whether it's downward,
I'm going to go ahead and just
negative 3 is going to a calculator. This is from A to C. 480 degrees. Where the x direction is going backwards, so negative 2 sine 20.
We actually don't even have an angle right here. 10 degrees. Negative 180. And this has going in the opposite direction. F3, however, in total 400
sine 30.
This force in the other direction. 112.
In the direction. It's going over 266.
Because they have force 200 newtons, just use vertical trigonometry. So the 2 cosine 1
so that would be the first one.
That is equal to
This right here,
positive direction.
Our result is 4 on the x-axis. So we can go ahead and just sum all of x,
and then in the z direction is 900.
And this should be I plus, for y, for the vertical, 800 plus 1 sine. Very similar, except we use sine 30 degrees.
So 80 is going to negative.
This time we actually get all of it to their respective sections.
And theta
100 degrees because
is the
add up
tangent.
X. So let's take a look at x here for F2. We actually don't
We need to figure out the resultant force. So force
80 times 5
AB
this force is
going to be FAB
the opposite direction
over
and this will come out to be times cosine of 30 degrees. And as you can see, we just really
Welcome to EDU
everything
World.
actually. U vector AB
cosine
over U.
5, 12, 13 triangle.
AB negative AB.
These square come out to
So, to begin, we need to write down Gauss's law.
cosine
is going to be, let me put this into a calculate degree. So we're supposed to measure clockwise from back here, that would be FAB, which I did not write down yet, but it tells us that FAB 983
y
21.8, yeah, it would be positive
plus 180 times 5 over
Okay,
do
so
that.
let's find the
We
electric
equal to our
field.
vertical component
So,
of our
right
resultant
at
vector.
this point,
Simple.
we are on the inside of the cell.
820.8
as measured is 20 pounds.
For y, for the vertical, and force 1.
And so I can take square
Very
root
similar, except y
times U vector AB.
2.
I'm going to use the component.
So here we are
AB, not CC. It's just 1.5 over the square root. 1.5 squared.
The square root of that sum. 72. So
Our inner shell
magnitude
Plus 1 squared. Plus 4 squared.
the result vector is x-axis.
So based on this, you have to calculate the magnitude of its component. So clearly, if x component is
Theta here, or sorry, the angle between the x-axis and force 1 is 10 degrees. 20 degrees.
That gives me
X-axis 0.9 newtons. Now we have to subtract 30 here really quick.
inside
I'm going to use this space to find.
let's see if that
When we do that,
which is equal to 42
8
over
Now
x.
here C less than R less than D, so now we're in this outer
So
region.
just plug this into the calculator as well. And once I'm plugging in for this
outer
problem,
region, I know that electrical field must
That is equal to
positive magnitude
because
T1.3
z component
In this problem, I just draw the three-body diagram. Now, here let theta is the integrate of the force F with the horizontal in the anti-clockwise direction and F are in the resultant force. On and phi is the inclination of resultant force with positive x-axis in the counterclockwise direction and alpha is the angle made by the resultant force with negative x-axis. Now I will apply the law of cosine
and we get
to the vector triangle, and the expression for OA square is equal to AB square plus OB square minus 2 multiplication AB multiplication OB cos angle ABO, or you can write the next expression as or OA is equal to under root AB square plus OB square minus 2AB multiplication OB multiplication cos angle ABO. Finally, you can write the value of FR as under root 450 square plus 700 square minus 2 multiplication 450 multiplication 700 multiplication cos 45 degrees. So you will get the value of FR as 497
FAC. So far, this section seems to be exactly the same as the previous one.
So I can write
Don't know. So it's 40 times. Seriously.
sine angle AB
angle between the
is
x
equal
on
to
the denominator,
AB by
30 degrees.
sine
It's
angle
also shown that this down here
or
is 45
FR by
Newton.
or FR by sine angle
Direction.
ABO is equal to
2 sine
40 by sine
this
angle
5 degrees, and it would be 45 degrees because in all cases it's right angle.
So you can write
2 cosine direction of the resultant force. Well,
sine 45 degree is equal to 450 by sine
x direction
15 degree plus
going to be
alpha
400
15 degree plus alpha
squared. I was
is
going to
equal
write everything
to
down.
sine inverse
30
450 by 497 multiplication sine 45 degree.
What I'm going to do is put 2 sine 20
Finally,
result in the y direction. If this go into
39.81 degree minus 15 degree,
put the 2
which is approximately equal to
800
25 degree.
minus
Phi angle is equal to 180 degree minus alpha, which is equal to 180 degree minus 25 degree. So you will get this value as 155 degree.
Force is going to
The
be the square
inclination of
root
resultant
of
force with positive
FR
x-axis
squared
in counterclockwise
plus
direction is 155 degree.
So we need
and then I have to
2q
square that.
so
Pi squared 27. And the angle is going to be 47.
And then what about on the outer
Oh,
side? So in this
it's the
example,
same
we have
question.
positive 2
On the outer side,
minus
45,
minus
tangent,
square that.
Oh, so this time we're told that f sub b is 600 newtons in the calculator, and for theta is 20 degrees. This is the same question, but actually easier. That theta is, whether it's kind of backwards or forwards on this one. Go into a calculator. Let's just think about 4.87 given basically everything we know. 1.975 912.6 minus magnitude and direction of the result. So F newtons are next one going to be 700 sine 30
10
minus 600, 30 minus 300. That's 20 degrees. It is 20 degrees. Cosine 20.
My y-axis is going to be the result.
Negative 318. Add them both together. 8.700 cosine 30 plus 600 sine 20. 600.
We're still not done. All right, now I squared
plus second one. FR is the square root of FR squared is 983. This equation. So let's just put those into the calculator.
FR equals
says that the closed
and theta. 700 sine 30 minus 600 cosine 20. The second one, or the y direction. In parentheses, 700 cosine 30 over the x sine 20. And square it.
on the inner shell first or
839 negative 22. Now this is question 47. Easier, and that is the correct answer. Continuation of the inverse tangent. So we're supposed to measure clockwise from the positive x-axis, so that would be correct. The y value, draw over the x value.
That it was a point charge and say
Put that in a calculator.
times minus 2q.
So those two are my answers. Let's check if that's the correct answer.
Inside
983. So yes, it is 21.8. Yeah, it would be positive 20.8 as measured alpha, theta, and gamma. Clockwise direction. Add the other equation. We've got a FR down here, which is 1.97. See how am I measuring this? Counterclockwise. There's a point A from the positive here.
What is the total
Y.
We have a plate that has 4 different forces acting. 41, 43, 44, and actually interesting magnitudes and angles for each of these.
Think about what's going on here.
function.
This
You can get out if you're outside of that.
FRX
So now what
is negative 213.
The extra angle tells us that force 1 and force 2
They cancel each other out.
FRY. That's a y-axis. Right, so using these, we have to actually find the resultant force vector and show that the resultant force is
There's a point 811 here.
0. So we can do this by determining all the x and y components and summing each of them individually to see that they both add up to 0.
We just have to change the mind.
Let's start with the
back to 0.
So the resultant would be here. So the theta that I measured is this. That I calculated is that,
magnitudes,
and that theta was 75 degrees, negative 46.7. It's going to be the square root of these triangles at 75 degrees. So if we're going to measure it counterclockwise from the positive it's going to make it here. So that's just going to be 15 degrees.
So for the whole
and that is correct.
The distance from A to B.
Okay, so now we can look at the charges that are around these shells.
We're going to be looking at use a regular trick, so SOHCAHTOA, right, to determine
the result is going to be
what the component is. So here, because we need to find
In the y direction,
the horizontal side, or horizontal component, we use cosine in SOHCAHTOA, which is adjacent to the hypotenuse. So here it's going to be
plus 2q. That's happening right here.
I'm going to begin
in the z direction, going down
and the force 2 plus, and here it's going to be so once again, but it'll be 3 over 5. So it'll be 6 kilonewtons. That's magnitude F2.
Check A to C.
Okay.
A to
And
C.
then what about
Well, in the x direction, it's going backwards, so negative
Times 3 over 5. And we can just add or sorry, you can actually just subtract force 3 and force 4. Because if you look in the diagram, both the number
No, it doesn't. Going over
out there.
2 look like it is plus
minus 2q.
2 cosine 20. So that would
only
be
way
in the opposite direction horizontally,
beta
and F1 and F2 are.
30.
So here we go.
Obvious.
And if we do this math really quickly, we'll actually see that this actually all adds up to 0.
Alpha's
So
going to be
we know that
cosine
our horizontal
direction
component
is just negative
comes out to 0.
negative 648
Next for our vertical components.
6
Right, so
7
let's get force 1.
I'm going to put that
Times 2 cosine 4 triangle. We need to find
direction in the XY plane to figure out the resultant force. So,
we're looking for the electric field everywhere. And
AB.
see if we can find
using sine. Right, and sine is opposite of our hypotenuse, so it's actually going to be 3 or 8 times 3 over 5. Heading down, actually add a negative in front of it.
Is going to be
Next,
let me put this into a calculator.
where the charges are.
And then we've got F3, FAB,
add
which has
100 force 2. Let's get this triangle and we vertical component. So we decide.
Let's go ahead and resolve F2 components. F1 is just U vector
Opposite over hypotenuse here is also force 4 over 5. 6 times
or less than a.
2
Well, we don't have any charges,
over the
so
square root.
that means
we actually see component to F3 or F4, right? The just horizontal lines pointing towards the left. So we start here and check if these add up to 0. And behold, they do. So we know that
30, which is F2xy,
if it is a connecting shell, less than r, less than b,
and then that's going to be the sine of
our
4.
definition. First, our small
both of these resultant components add up to 0, so we know our resultant force is 0. F R
negative
That's that.
negative 4. Leader diagram 6j cosine
12.
30.
What is the total
is going positive x. In the z direction,
now
it's
we
going
do have some
negative.
charge. We have the total charge on the shell plus 2q
Negative
4 pi epsilon.
F2. So now the denominator becomes
well,
first of all,
field of
32
charge
FAC
equals.
All right.
There it is.
40 times. F1 only has an x component. I'm going to write it down. So it's 40 times
c less than r less than d.
X is
C less
no, in
than
the
r
denominator.
divided by r squared.
That's all it's done.
And then
we can use this
add that to
in our
F3.
It must be 0.
Negative the result sine
the electric
20.
field E equals
Square.
Welcome to
E
EDU World
Positive
Space.
y-axis.
K
2 plus 2
So
cosine
what happens if we are
F1
outside of everything?
plus
So
F2
now what
x
happens if we
plus
are
F3
doing
squared
Gaussian circle
squared be
outside of
0.
the system? Is just, well, what is the total charge
plus 4
enclosed?
squared, which is 16.
Plus 2q. We can write this minus 2q.
All right.
That equals
So
divided by 4 pi epsilon.
the numerator is negative 2 sine 20.
Times
Here's
2q.
to be after we go inside draw the diagram can draw here. 6 I'm going to put that 2
So the inner surface so smaller
3
the region
and now negative 4.
So charge on the inside. There's something induced inside that conductor.
F1. I need to add those together to get the resultant.
And then finally,
I
to
Y.
cube field
Welcome
due
to
to
point
charge,
6.
and we get
So
our large E shell.
3Y
We go
is
right on the
23
diameter right here.
And that's
minus
divided by
F1. 23. And we're still not done. So F3.
Then what about this outer surface? Regions? Now we can go ahead and graph this.
Z
zero.
is the
We have
opposite.
net charge of
F1
something like and we have E
Z. Using this equation. So is going to be putting that into a calculator. Wish you could see my calculator, but it just slows down my computer way too much.
Okay.
To have it be
and
recorded.
We are going to get between region
A and
B.
I just need to tell you what I'm doing. So I'm going to do F3 here. So it's going to be negative parentheses. F1X.
Originally,
where's my F1X?
0. No charge.
Negative 185. And we know that plus
so it goes as a
F2
problem. We have an inner shell and an outer
shell. Check
Yes,
it is.
This time,
the first thing that I want to do is I want to find that chord out. So that X, which is 0.97. Over FR, which is 52.1.
So
putting that in again. The opposite of that plus that. Which is just going to be the force. Which says 600. Minus F1Y, which is 80 total charge 7.8 degrees. Minus F beta.
We have no charge there.
Numerator 23.
And this is our area. Okay, A plus
the resultant force is going to be inverse of divided by the those are correct.
That means that Q is 0.
401.
Q is 0. E.
Okay,
what about the outer?
With the x-axis.
Okay, F3Z is just going to be the
We've
got two equations. So let's go ahead and get that. Put all of these into a calculator. So the first two components is just negative, negative, positive. So
by definition,
down
the word after the term
Q.
Alright, so we are given F1, it's along the negative x-axis, it's a force of 180 pounds. We're also given F2, 300 pounds.
So I see that wait a minute. Theta let's check it. So 100 gives me an coordinate direction of F3. So now I need the magnitude of F3,
which is 1 over
F3.
epsilon or 9.
I'm going to put negative. Let me put that. 30 is the calculator. Tangent of theta negative 0 X direction is going to 1 negative y is 1.
It means that
F2 is complicated.
taller.
Y direction
slice out
a little more 3K.
right there.
Calculator right
This black line is actually F.
Indeed.
Right,
So now we are in
We
this
are
outer
told
Where?
there's a
420.
Well, we are in this outer ring.
30 degrees.
Remember that the
Gamma, I changed the numerator to negative 4. This and gamma. Let's go back to BA. We need an negative y, which would just be the x, y, and z coordinate. The numerator. Those are except about whether or not negative 97.
So it's going to be opposite over hypotenuse. You can plug those in. So something
and gamma.
This is O.
Zero
plus
times 6
Then
divided by 2
you can determine,
you have
do the same method.
degrees.
9 times. Now it is going negative. We've got in the x.
Calculator as well.
First one's going to be
origins. Now we can go ahead and solve this.
degrees. Using the calculator,
as well as
we're also doing F2 down here.
So
That's easy. I'll check it out. It's going to be 5 degrees. Okay, now what are we doing here? The result is just going to be the 5
both of these sides actually to find
Be a
this
little
side
steeper.
and this side. See, we're given the magnitudes of
F30 minus 800 sine.
Now, what about the
40 degrees.
inner surfaces?
30 degrees opposite over
The resultant force is going to be the square root of FRX squared plus A square root. We need all three forces in Cartesian.
So in order to solve this type of problem, we have to
Welcome to
Where 3.61 going to 6.51. So the only difference is the book writes it put all of these in the calculator.
Force one, and this is write this in to be I and J vector form.
0.
So we have a root of component.
I guess they're showing at going to calculate and the outgoing to be of the x. And so, okay, that makes sense. Wait a minute, very good.
2, write this in blue so we can keep an eye on it. Equals the x component, which we just learned, is this one right here. So this is
It's going to be negative 5.
right here. Sine of 75. So J. Plus, the reason we'll just round to 199 J. And lastly, our z
And
component.
what
Subtracted
about
the first term or had -4
Negative.
to the first terms because
So,
although
I'm
we're going to go to
multiply that
Come to the channel, here with X complex questions and break them down into simple step-by-step solutions that solve the problems together.
some value x. We don't have f3, but we know what the sum needs to be. So for now, we're just going to put a temporary xi plus yj plus zk, right? And x, y, and z are values that we're going to
Okay, so let's just
plus 167 plus x
And
actually,
equal to 0.
fr,
Our result
determined
force
here.
vector. Because we can figure out
substitute
everything.
I'm going to repeat this with y.
change zero on the horizontal axis. It's 3 degrees. Now let's calculate the horizontal and vertical component of
I'm do this with z.
Write this out.
That's just the total charge.
Equal to times 3. Similarly, we have vertical component
So we're going to just go ahead and write this out. Equals 13i minus 190.
Units on this. We would expect that
Remember,
this
our task is to find the magnitude of this. So
plus
basically
6
square root
has to
sum
equal
them
this.
and then take the square root of
This
that
is 6
sum.
divided by 4
So I'm going to do that really quickly.
equal to sine squared of 30 degrees, that is 150 newtons. Now for change CD, the horizontal component is f3.
F3 equals
Equal to SC times cos of 60 degrees, that is 250 times cos of 60 degrees. The vertical component of FCY equal to 125 times square root of 3 newtons.
There's formulas we can plug our numbers into. So alpha.
Could have been 42 on my answers. Let's check.
So that's the cosine.
Equal to 150 times square root of 3 squared, 150 newtons, and the cosine
F3 here.
in Cartesian
Go
vector
ahead
form
and get
is
to 39. Really,
Namely,
really a continuation. Although this is
This is
simpler
1.5
than
times
60 over this way. I do have my not the x direction is 30.
7 degrees. Beta.
Vectors, 500 pounds. And you have the x and y direction is going to be in the I direction, and the j direction.
Here with X complex questions and break them down into simple step-by-step solution that solve to this.
7 degrees, or somewhere around there, depending on where you round. But and these are our final answers. These are the coordinates.
Which, by the way, make this express each as a
This is a bit of a long problem,
Cartesian
but hopefully you
vector. At least this diagram. And then we have the Pythagorean theorem. So I'm going to type in this array because I like to draw them tail to tail squared.
Next step is to find the angle of
So in this question,
Done.
For the region
do this by
It's a little bit harder to interpret, though.
over the x component. So eventually
Let me go ahead and draw.
y.
I'd also like to get rid of this.
Just
what I can do here. I'm considering where 30 direction is. Okay, 4.5 square. And that's so F1. Okay, 2. So continue this through. We've got.
And this angle is actually the angle between
Based on this, you have to
Oh,
find
what amounts to that's
and
that's 53.8
down here
down
looks like this.
Okay, so did that one. Components. Sine 40 at the end.
the total x component of all this.
See here,
Easy one.
F1.
Definitely an easy one. There's a point A to be up here.
Sine 130
This angle
is just going to be 40.
This angle.
Grid 43 degrees.
This
Sine F1
5 degrees. This is
which is just the square root of 2.
And this is 53. Guess that's it for that one.
54 newtons
I
at 43.5.
Oh no.
And the same
This
thing
is
that is in
yeah.
the positive x direction.
These are all
In the
feet.
j direction.
Degrees
With the y
minus F2 is 26.
And so far this section is 400 times better than
Point C though here. What is difference here seems harder to visualize.
in the x direction is going to be the cosine 0.5
of
j
30 degrees,
and the
and
cosine of
the
30 degrees
direction
is the square root of 3.
of the
Over
result force,
2.
which is directed
This
along
is just going to
positive
be,
x
and then it's
prime
going
axis.
to positive 50, whoops,
And that axis has
negative 1.
is
Is also shown that this down here
with the y-axis
is just 45
degree
degrees.
with the x-axis.
This is 2 feet. And the angle is 1. So I'm going right to green.
The magnitude direction of this.
Well, I'm going to indicate that this is
in the
You have to
x
actually break
direction.
down all of those
Two
equations.
times
And add them up. So
130
plus 800 result
800
vector.
cosine.
And this is 2 sine result, and then the y direction is going to be
Alright, so the distance from A to B minus 2 is going to be negative 75
Some value j.
I.
So it's going to be in the x direction is going 1.5
squared.
This is 3.49 kilonewton, right?
So it's just straight upward, so it's not even any horizontal
in the y direction is going to be negative
Inverse tangent.
from 2 to 3, so it's only negative 1 foot.
Y over
It's a 5, 12, 13 triangle, which is a right triangle.
Squared
And for the
and
new
complete
plane,
root of
which
that.
will be
So it's coming
all of these into a
Z
calculator
direction is going down
4, but you know exactly where that theta
vertical
is,
and
whether it's
horizontal
actually
direction.
here, downward,
Go ahead and just
AC, so
components.
negative
We
3
define
going to a calculator.
horizontal
This is
y is 3.49
which
over
will be at
this
the
is
point B.
16.8.
from A to C.
So we need to use
400
So in the x direction is going backwards, so it's negative 2 sine 20.
We actually don't even have this angle right here, negative 180, and this has it going in the opposite direction.
Next one.
F3, however, in total,
400 sine 30
this force is going in the other direction, 112.
In the direction.
Problem.
It's going to be over 2
triangle.
Vertical trigonometry.
This angle
26.
So
Exactly
the 2
cosine square root
That would be
the first one.
this right here,
Go
5
positive direction here.
Our result is 4.
So let's put them.
So epsilon x is just
Go ahead and just sum all of
and then in the z direction is
Is
negative
900.
5.
So F1
Plus,
is
for y, for the vertical,
negative
times 1 sine. Very similar, except we use sine
30
degrees.
angle 34.0
sine
30 degrees. I, 80
is
going
negative
this time we already get plus and theta.
30 degrees because what's so let's take a look at x here for f2. We actually already
need to figure out the results required. So the sine
x that, y that.
Force of 30 degrees. AB 100.
This force is going to
be over 15.
This will come out to be times cosine of 30 degrees.
The cosine of 30 degrees is the square root of 3 over 2. So that will be u vector AB over u.
And it will be
it's negative 26.
2
times 513.
So to begin, we need to write down Gauss's law.
Cosine
is going to be, let me put this into a calculator. 23. So we're supposed to measure clockwise. F2 is negative 10. I just simplifying. So that would be FAB, which I did not write down yet, but tells us that FAB 983 the work 21.8. Yeah, it would be positive
plus 180,
and that's correct.
5 over
Okay, so let's find the electric
equal to our
field.
vertical component of our resultant vector. Simple.
We are on the inside of the
So
circle.
820.
So here we are given three forces. So let me just write
20.8 as measured is 20 pounds.
One for the vertical and
So I can take the square root
similar to y
times u vector AB.
sort of like this.
I'm going to use the component.
So here we are given
which is 1.5.
is equal to 300 into 10 raised to power negative
and the values are in
over the square root of 1.5 squared.
Our inner shell.
Plus 1 squared. Plus 4 squared.
next here you have given the
that is acting in the
so based on this you have to calculate the magnitude of its component. So clearly if x component
maybe here or sorry the angle between much more
based on this you have to find out
force 1 is 10 degrees.
magnitude of the resultant force equal to
That gives
build the circle.
Now this is pretty
and
simple.
for
So what
that
you can
we
do
need the
is
x's, and we are going to use the
you can take the total x component of all these forces. So starting with F1.
We have OC
So
that is
F1
equal
sine
to
of
the
40 degrees
average
because if you see here the
value
40
of the
degrees
strain
makes
by
an angle from the
0
vertical side. So the perpendicular component
Charge inside
plus
space.
F3 will also
right,
component
and
to
we
the right.
calculate it
So
together is equal
F3
to 425
cos of
into 10
30
raised to power negative 6.
plus
So you just plug this into the calculator as well. Once I'm plugging in this problem.
First of all, let's write F1 value which is 15 sine 40 degrees plus F3 is 36 cos of that is equal to minus
T1
cos z component.
In this problem, I just drew the three-body diagram. Now, here theta is the integrate location.
So let's see how much we have here now.
348.2 into 10 raised to power negative 6.
Force F with the horizontal in the anti-clockwise direction and F is the resultant force. On and phi is the inclination of resultant force with positive x-axis in the counterclockwise direction and alpha is the angle made by the resultant force with negative x-axis. Now I will
1 cos of 40 now.
The point
This is
A
vertically
at
upwards.
which
Now
the
minus F3
rate of
sine of
strain is
30
occurring, right? So
This is vertical
apply the
downward.
law of cosine
right?
to the vector triangle, and the expression for OA
are easy
square
Same value.
is
Of course,
equal
I'm going
to
to draw
AB square plus
Cos
OB square minus 2 multiplication
is
AB multiplication OB cos angle
we have
or
plus 26 sine alpha is 5
and
over
the
13
other principal strain is OC plus R,
perpendicular
right?
by
Again,
hypotenuse.
you have the
you
value.
can write the next expression as or OA is equal to under root 4 AB square plus OB square minus 2AB multiplication OB multiplication cos angle AB.
So these are the two components you have got. Both are positive components.
Finally, you can write the value of FR as under root 450 square plus 700 square minus 2 multiplication 450 multiplication 700 multiplication cos 45 degrees. So you will get the value of FR.
So it's coming out to 17.1.
497. This is the magnitude of the
this section seems to be exactly the same as the previous one.
so I can write
Don't know, so it's
OA by
40 times. Seriously.
sine angle AB
So on the denominator,
sine angle
also shown that this down here is 45 degrees.
That we can
Right, because it's in the first quadrant.
we can
itself.
directly have the
I hope this
expression
is clear
for
to
the
you and have a very
maximum
good rest of the day.
value
Thank you.
the strain, a shear strain, right? That is maximum.
So far this section seems to be exactly the same as the previous section. Don't know.
FR by
What is
sine
different?
angle
Serious direction.
ABO
This is also shown that this down here is 45 degrees. 45 degrees right angle to cosine is rather the result as well.
Sine
Is 45 degrees, which is the force right angle. Result the magnitude and direction of the result 400
15 degree plus alpha
squared. I was equal to
sine inverse
30 is going to be 400 30 plus
45 degree
800 sine result in the y direction. Force result in the y direction is going to be 400 sine 30 minus 100 sine. Put the 230 minus 800 sine. The resultant force is going to be the square root of
180 degree minus alpha
squared plus F Ry squared,
which is equal to 180 degrees
the angle
minus
is going to be
25
inverse
degrees.
tangent FRY over F. The resultant force is going to be the square root. Put all of these into a calculator. It's important that you do the first two, since you know exactly where that theta is, whether it's downward or upward, horizontal. 27. So, going to a calculator.
XY. So this is
400 goes to 3,700 cosine 45. It's the same 912 sine 45 tangent. Square that.
P comes out to
Newtons.
83.0.
Okay, next one. So this time 400 sine 30, that's 800 sine 45. Negative 366 newtons. Sub B is 600 newtons. This is a calculator. The first two is 20 degrees. This is the same question, but actually easier. That theta is, whether it's kind of like
the tension that is applied is over here is of magnitude 2
squared is 900. And going into a calculator and let's just think about
4.87 given basically everything we want. 900.
And as there is only torsion present,
over the x minus magnitude and direction of the result. So F newtons are x is going to be negative 700 sine 30
strain, right? So
21.8
it means that
degrees.
The strain in the
So we're supposed to measure clockwise from the positive x-axis. So that would
minus 600 30 or my answer is 20 degrees is 23
cosine 20 21.8. Yeah, it would be positive 20.8 as measured 300 in a clockwise direction.
Is the strain along the x dash direction is equal to the
so again, drawing the diagram and figuring out what it means, most of the battle is 30 plus 600 sine 20. Why? And we're still not done. Z squared plus x. And we continue the z axis downwards. The square root of, we're given f1.
Strains along the x and y
which
equal to 0,
appears to have no x component.
So that's going to be convenient.
80 this equation. So let's just so it's a 3, 4,
the calculator
equals triangle, but it's got no theta. 700 sine 30 minus 600 cosine 20. Okay, square f1 in parentheses 700 cosine f2 has all three components. 600 sine 20.
Right, so
but the angles are directly given. 839 negative 20 newtons 2. Now this is question 47. Easier, and that is the correct answer. Anyways, everything is tangent. So we're supposed to measure, and the angle with y is 120. So yeah, they're all directly given.
So again, these two terms.
So let's go ahead and do F1.
And
F1 in the x direction is 0. Would be correct. The y value 1 in the y direction is, well, it's going in the positive y direction. 3/5. Those two are my answers. Let's check. Check 405th answer. 983. Well, 45 divided by 5 is 9. Yeah, it would be 9 times 3 is 27. So that's going to be 207. Gamma positive direction. F1 we've got is going to be 4/5, which is 1.97. See how am I measuring this? But it's in the negative direction. So that's going to give us negative positive 60.
What is the total?
Y. So let's move on to F2. This is actually all pretty straightforward. Interesting. F2. Think about what's going on here. Is just going to be the 525 is negative cosine 13 of x direction is going to be 45.
And this is equal to negative
F2y is 525.
0.005
cosine of the y direction line.
Right, so using these, we have to actually find the resultant force vector and show that the resultant force is
F2z is just going to be
0.
525.
And the x and y components, summing each of them individually to see that they both add up to 0.
Just have cosine z, which is 60 degrees. The result. So this y one should end up giving us a negative number. The other one should be positive, would be here.
So let's put them
into A that I measured is this. That I calculated is that.
Magnitudes.
And that 525 that sine of 545 negative is 371.2.
The strain acting in the y direction is equal to
Newtons.
720 into 10 raised to 1.
525 cosine 120.
And the shear strain is
Square root of these triangles at 75 degrees. So we're going to measure 62 counterclockwise 5 and 525 cosine 60. So that's just going to be just going to give us 262.5 newtons. Okay, so now we have to add them together. Adding the x components, well, there is only one, and that is the distance from A to B.
Okay, so
that's going to be this time I'm going to write it in vector form. 371.2 to be I. The result is going to be F. So now I'm going to do 270 minus 262.5. I don't trust myself, so I'm just going to do it. 270 minus 262.5, 7.5. Thought so.
And that is equal
We use cosine instead of
plus 7.5j. And then in the k direction, we've got negative 360 going down to 262.5.
Plus. And here it's going to be
under root the
Going to give us negative 97.5.
So once again, we're going to do 3 over 5. So 6 kilonewtons. That's 9 F2.
K direction. We need to sketch the vector and find the magnitude and the angle. Well, sketching the vector is what I would do next. We've got 371 negative in the I direction.
And we can just add.
Then we've got 7.5 in the J direction. And then we've got a negative K direction. 2, like it is. So it's going to be like down and over there. Maybe something like this. Obvious.
And if we do this math really quickly, we'll actually see that this actually all adds up.
So now,
as you can see,
F sub R.
That
to 0.
Square root.
So we know that
371.2 squared
comes out to this
7.5 squared
vertical components.
Plus
So
negative 97.5 times 2 cosine 4 triangle. And a calculator. Direction in the XY plane to figure out the resultant force. So,
we're looking for the electric field everywhere and see if we can find
sine. Right, and sine is opposite of hypotenuse, so it's actually going to be 3 or 8 times 3 over 5.
Third is going to be calculator. 371.2 over 384. We got F3, FAB, beta, and gamma are going to be very much the same.
So sine.
Let's go ahead and resolve F.
And that is approximately equal to 946 into 10 raised to
9 times 1.
So
just do
The opposite of hypotenuse here is also always 4 over 5.
Inverse cosine.
Once again,
or less than A.
2
So
of 371.2 over
maximum in plane
F sub R.
Right.
14.8.
Divided by 2 and equal to R, right? So we are
Well,
going
we
to
don't have to
Suppose
define
we're
what
5 in the numerator.
We actually see that component to F3 or F4, right? The just horizontal lines pointing towards the left.
Negative 97.5.
Add up to 0. Lo and behold, they do.
100.
So, we know that
Now I'll check it.
30,
which is F2xy.
If it is a connecting A less than R less than B,
and then that's going to be the
we're in
sign
the
of
star
4.
definition. First, our small
both of these resultant components add up to 0, so we know our resultant force is 0. F R
Negative 4. These diagram 6J cosine 30. 3
together would be
I'll begin by drawing the diagram. In the z direction,
Now
it's
we
going
do have the
negative.
charge. We have the total charge on this shell. Plus 2
A
q
negative
4 pi epsilon.
y, x, z. There are 3 forces. So now the denominator
Times
becomes,
well,
first of all,
field of 32 charge.
FAC
Squared equals.
All right,
there it is.
F3, 40 pounds, which is vertical. X component, I'm going to write it down. So it's 40 times 1
Welcome to EDU World Space.
X is on the denominator. One that appears to be in the
So we are looking at outer shell of minus 4 q charge, and we're going to find the electric field everywhere. So to begin, we need to write down Gauss's law. The closing
and then we need to add that to F3.
It must total
negative the resultant 20.
Also remember that when we have
Welcome to EDU World Space.
Since F1 is plus the
K just a constant.
F2
What is the total charge? You can also write a square.
Right angle easier in there, but
epsilon
I
naught.
believe that's what they are showing us.
Okay, so let's find the electric field. Total charge
plus 4 squared,
right
which
at
is
this
the writers are showing us.
minus 2 inner shell.
All right,
That is
so
by 4 pi epsilon.
the numerator is negative 2 sine 20 using proportions
0
is 4/5 of 90.
So 0.
What about diagram can draw here. 6 I'm going to put the 4.87.
B less than R less than C. We're in this first ordered region.
Okay.
Our inner shell.
F7 that's going to be okay. No, not Y.
And so that's so.
And now negative 4.
So writing it like that, we get
54
1 divided by 4 pi
newtons, and they are both
epsilon 0
in the positive direction.
Times the total charge inside F2Q.
And to add those together to get the resultant.
And then finally,
Welcome to
EDU 0 here in this region.
Sorry about that. I was
because
thinking about
when here, so I need minus 2q
we
on this
are
inner
given
surface.
that its projection
E still
onto the XY plane,
and we get we are
F3
is take the total charge
minus and we're still not done. So in the XY plane,
we can go ahead and graph
is F2.
And what do we see? Then what about these outer surfaces? Now we can go ahead and grab
3 times
zero.
the
We have zero.
cosine.
We have
Opposite.
negative
6
there,
times
graph it,
1.
something like
Plus
that. C, and we have E, C.
Using this equation.
Again, I got
putting that into a calculator.
Wish I could. You could see my calculator, but it just slows down my computer way too much.
Okay, even
to
though
have
this
it
is
be
recorded, we are going to get.
All right,
you can get out.
So
your graph
now
calculator.
tell you what I'm doing.
And
So I'm
see
going
what
to do
happens.
F1
What about
here.
F2?
X is going to be negative parentheses.
F1. X1.
Originally,
Where's my F1?
0.
X.
Your
Result.
Negative 1
And we know that
plus
it goes
as
as
2x
times way.
So
Sine of 45 degrees equals the cosine of 45 degrees, which is the square root of 2 over 2.
Checks that direction is going to be the same. Yes, it is. The first thing that I want to do is I want to find that chord out. So that is over FR, which is 52.1. Okay, putting that in.
The opposite of that is
0, which is just going to be the force.
okay, so now we can look at the charges that are around
F2
negative y,
which is 600 minus and that's minus F theta. Have numerator 23
and this is how
the result, of course, is going to be divided by the correct.
That means that Q
is also in the positive direction.
Okay, what about the outer?
200.
What about on the outer surface?
Okay,
a little bit surprised that everything is going to be
got two equations. So let's go ahead and get that.
Put all of these into a calculator. So the first component is
Q.
So we are given F1 it's along the negative x-axis, force of 80 pounds. We're also given F2 it's 300 pounds.
Plus,
so I see that wait a minute. Theta square.
That's checking. That's
direction of F3. So now I need the magnitude of I'm going to put negative. Let me put that. Negative 0 X direction is going to be 1 negative 1. Y is 1 they're
complicated.
Taller.
Y direction. So 3 diagram 3K.
Alright,
pipeline is actually
so
F.
Go ahead and
radius
draw.
less now we're
What I
going
got
to
square.
There's
okay?
420.
Well, we are right here. Remember that the
Gamma, I changed the numerator to negative 4. Gamma, you go back to BA. We need a negative x y, which would just be that x y is 5 in the numerator. Except you see about whether or not negative 97.
So imagine that it's 2 parts.
Gamma 4.
Alright, now we're in our
Then,
C less than
point C back here.
C less than D.
9 times. Now,
Then
it's going negative, but it's got the hypotenuse. The first one's going to be in the angle. 20. So, 3 degrees gamma. Using the calculator.
As well as
This is going to down here.
0.
So that's E. Just going to be the 5 Okay, we're going to B direction, going down
To be charged, enclosed
And
here.
as I see, we're given the magnitudes
sine 30 minus AC.
Now, what about the field?
40 degrees.
Charge.
The resultant force is going to be the square root of FR, and the x direction goes back square root negative. I see all three forces in Cartesian.
So in order to solve this type
We
of
know that the
problem,
electric
So the only difference is the book writes put all of these
of 0. We have a net charge of 0 here.
This write this into the I and J vector form.
And then in the z direction it's negative 4. So I guess they're showing the echoing time is going to be of the axis. And so, okay, that makes sense. Wait a minute, very good. Resultant force.
So you can keep an eye on it.
So, force
equals the x component, which we just learned, is this one right here.
FAB.
So this is
Is going to be negative 5.
right here, sine of 75. So J.
F
For the reason, we'll just round to 109.
Welcome to EDU World Space.
is going to
Unless
be,
the
let me
RZ
put this
I
into a
the
calculator.
first term or has negative 4.
FAB
multiply that out.
Some value so for now, we're just going to put a temporary xi plus yj plus zk, right? The x, y, and z are values that we're going to plus 157
total charge that is enclosed in our region divided by
our result terminator, because we can
figure out this is our Gauss's law.
That gives
this
me
with y.
And this
Change theta and horizontal axis. Extrude trace. Now let's calculate the horizontal and vertical component of
which is radius is less than x.
We're going to just go ahead and write this out.
18 point
equals 13i
so E equals
minus
0.
193.
Alright, what about if we are in between A and B?
Find the magnitude of this.
So now the denominator becomes,
and then take the square root of cosine.
By definition,
FAC according to the book.
it must have
equal to 0 times sine of 30 degrees, that is 150 newtons. Now for change CD, the horizontal component is
F3
I'm putting
FC times cos 60 degrees, that is 250 times cos 60 CY equal to 125 times square root of 3 newtons.
Next formulas we can plug our numbers into.
just in general, we know that the formula is
my answers. Let's check.
And proceed.
7.
In Cartesian vector form,
really a continuation, although this is simpler than I do have my not the x direction is 30.
Right here is the total charge.
And now negative 4.
Our square
vectors, 500 pounds. And you have the x and y direction is going to be in the I direction. Y direction, and the J direction,
here with x complications and break them down into simple step-by-step solution. That's all to this.
6.84 minus.
Somewhere around there, depending on where you're at.
Okay. Now what about the region
These are our final
C
answers.
and D? So now we are in this
I
outer
express as a 27 Cartesian vector. At least this time, and then we have F2 the Pythagorean theorem. So I'm going to type in square root because I like to draw them tail to tail squared.
Next step is to find the angle of
Done. 2.
Do this by
It's a little bit harder to interpret, though.
So eventually,
let me go ahead and draw. I'd also like to get rid of this. Just what I can draw here. Considering where the direction is, this will get 1.5 square, and that's going to be 1. Okay, 2. So continue this through. We've got,
and this angle is actually the angle between
Based on this, you have to
Oh,
find
what amounts to that's 53.2 down here looks like exact. Okay, so that one component. Sine 40 at the end.
the total exponent, right?
See here, easy one. F1. Definitely an easy one. There's a point A to be up here. Sine 130.
This angle
Is just going to be 40.
This angle.
Grid 43 degrees times this sine 5 degrees. This is 4. This is 2. 53. Guess that's it for that one. 4 newtons. Oh no. And the same thing is 1 positive x direction. Now the j direction
and between regions B and C.
So far this section seems to be exactly the same as the point C value here. What is this one? Seems harder to visualize. The x direction is going to be cosine 0.5j degrees, and the cosine direction is square root 3 over 2.
Which is directly
This is just going to be, and then it's going to 150. Whoops. Negative 1.
With the y-axis
is just 45
with the x-axis.
This is 2 feet. And the angle is 1. So I'm going right angle. Green. I'm going to indicate that this is x direction.
Add them up. So
130 cosine. And this is 2 sine 12. And then the y direction is going to be Alright, so the distance from A to B 2 is going to be negative 7.5 So it's going to be in the x direction is going 1.5 squared.
Okay, what about the
And it's in a 5, 12, 13.
kilonewton, right?
It's a straight up vertical, it's not even any horizontal.
And the y direction, we've got F. And it's going to be negative. Inverse tangent. From 2 to 3 is only 1 foot.
It's a 5, 12, 13 triangle, which is a right triangle.
Okay.
And what about the resultant? All of these into a calculator direction going down forth, but you know exactly where that theta is. Whether it's actually here, downward, going to a calculator. I'd like this to be farther
Gaussian surface right here.
left. From A to C. 400. The x direction is going backwards, negative 2 sine 20.
It's going to be negative 100. This has going to
Next one, sine.
Total
400 sine 30 plus after 2 in the direction plus negative 2 triangle.
Vertical total charge 4 plus 2.
26. So the 2 cosines we've got would be the first one. Simplify that.
And that's that.
this right here, 5
Positive direction here.
our result is 4.
So let's put them is 20. Times 5 is 100.
Go ahead and solve all of
And then in the z direction is 900. Result in the y direction
plus for y for the vertical
negative
plus 1
f1
sine.
cosine.
Very similar. It's almost
30
degrees.
minus 260 sine 30 times 12 13. 80 is going negative
This time we actually get
plus
the
that and theta.
100 degrees because
D is going to be 26 divided by we need to figure out the results required. So 12 is 240. The sine.
X that, Y that.
Now we're told force of 30
AB
is 100.
This force is going to be
FAB over 15. Well, the result
cosine of 30 degrees.
the cosine of 30 degrees is the square root of 3 over 2. That will be U vector A square root over U.
And it will be.
It's negative 26. No, it's not. It's well, I can grab 2 times 513.
So to begin, we need to write down Gauss's law.
Cosine is going to be, let me put this into a calculator. 26. So we're supposed to measure sine clockwise. F2 is negative 10 squared. I just simplifying. That would be FAB, which I did not write down yet, but it tells us that in the book, FAB, what's that result? 21.8. Yeah, it would be positive 450. And that's correct.
Okay, so let's find the electric field.
Now, also,
simple.
We are on the inside.
We want inverse tangent.
So here we are given three forces. So let me just write
20.8 as measured is 20 pounds. 35 minus 40 is square root over 9. U vector AB plus 300. I'm going to use the
So here we are given
which is 1.5.
Is equal to 300 into 10 raised to power negative.
and the values are
over the square root of 1.5 squared. Here in decimals, I'm going to let that's 1 square plus 4 squared. Here,
next here you have given
is
the
y.
That is acting in
so based on this you have to calculate the magnitude of this component. So clearly if x component is
Beta here, or sorry, the angle that's
based on this you have to find out
force 1 is 10 degrees.
magnitude of the resultant
That gives x minus
So this
240
is pretty
and
simple.
so
So
for
what
that
you can
we
do
need the
is
x's,
squared
and we are going to use
plus
the
you can
equation
take
10.13
the total x
formula.
component of all
sine
these forces.
x
So starting with f1.
plus
We have
So
300
f1 sine of 40
squared. And tangent of 30
because if you see here the 40 degrees
means
means an angle from the vertex. So the perpendicular component
Charge inside.
the y value, which is y
to the
cosine
right.
x
So
minus
f3
240
cos of 30
over
plus
this case, give that
which is equal to 40.
8. Now let's think about 5 appears to be
Just plug this into the calculator as well. Once I'm plugging in
0 and 9.
First of all, let's write f1 value which is 15
And
sine
the force is probably somewhere 200 or
plus
300.
f3 is 36.
So I'm going
Cos
to
of
scale my
minus
x-axis
T1
from z component
In this problem, I just drew the three-body diagram. Now, usually theta is the integrate of
and I'm going to scale my y-axis from 0 to like
into 10 raised to
500.
power negative 6.
with the horizontal in the anti-clockwise direction and FR in the resultant.
Didn't take. 0 to 90.
On and phi is the inclination of resultant force with positive x-axis in the counterclockwise direction and alpha is the angle made by the resultant force with negative x-axis. Now I will
that
cos of
this
40
is
now.
So
the
complicated,
point
Desmos doesn't
This
want
is
to tell me what
vertically
it
upwards.
is,
which
Now
but I'm going to
minus
zoom in till I
50.
can see it enough.
state of
Sine of
strain is
30.
occurring, right? So we
This
need
is
to
vertically
measure
Apply
downwards.
the
Right
law of
angle.
cosine
right?
F to
And
the
here.
positive
We
flex.
will
the
take
vector triangle
What about
and
26 sine
the
alpha
expression
is
for
10.9
4k
these are
degrees.
easy to
is
find
square
out.
same
Of
value
is
course,
equal
we're going
to
to draw
ab
a
square
diagram.
plus
cos of
ob square minus 2
And
multiplication
470
ab multiplication ob
here.
cos
Alright.
angle
We can go ahead and
abo.
graph.
And this is 56. There's no answer in the book.
Or
10
plus
makes
46
sense.
sine alpha is 1 over
473
30.
The other
newtons.
principal strain
It's a little
is
higher than I thought it
OC
was going
plus
to
R,
be.
Perpendicular
right?
by hypotenuse.
Again, you have to
18
value
You can write the
Again,
next
let's see
expression
what
as
is
here,
what.
or
but I
OA
don't
is
think
equal
it
to
is
under root
not
2
There, finally
ab
we
square plus
especially since
ob
it's
square minus 2ab multiplication ob multiplication
write the other
cos angle ab.
Okay,
So
problem
these are the two
62.
components you have got. Both are positive components.
Find the
These are
immediate value of
force
f r as under root
now
450 square plus 700 square minus 2 multiplication 450 multiplication 700 multiplication cos 45 degrees. So immediate value of f r
Is the
That is coming out
force,
to be 17.1.
but the XY component of the force
497
FAC. So far, this section seems to be exactly the same as the previous section.
so I can write
Don't know. So it's 40 times. Seriously. So
sine angle
AB. So in the denominator,
AB
degrees.
sine angle
Also shown that this down here is 45 degrees. So F is going to be 7
Because it's
over
the first
cosine
quadrant.
can
30.
directly have the
I hope this is
expression
clear
for
to
the
you and have a very good rest of the day.
maximum
Thank
So
you.
let me get that.
a shear strain, right?
Graph
That
and
is
calculator here.
maximum
7 over cosine. So far, this section seems to be exactly the same as the previous section. Don't know.
f r by
Result. Now, what is
sine
different?
angle
Seriously,
ABO
section 2 says this is 30 degrees.
sine
This
angle
also shows that this down here would be 45 degrees. 45 right angle plus 2 cosine the direction of the result of
law. The closed line
y
integral or the closed looped integral of each
as well.
sine
It will be 45 degrees, which is the force right angle result of magnitude and direction of the result for 100 here.
15 degree plus alpha
And so, the result
sine inverse
30 direction is going to be 400 in the
multiplication sine
30 plus
45 degrees
800 sine 20
on the inside of this inner shell.
times
There is no
the
charge here. If there is no charge, then
y direction, the force result in the y direction is going to be in the y direction 400 sine 30 minus 400 put the 230 minus 800 sine. The result of force is going to be the square root of
180 degree minus alpha
squared plus equals F. F r y squared
which is first
over 7. So F sub z would be 7 tan
and 180 degrees minus 25 degrees.
It's also
We get this value of
the result of force is going to be the square root. Put all of these into a calculator. It's important to do the first two, so you know exactly where that theta is, whether it's downward or upward. 27 minus theta. Going to a calculator and an F.
There we go.
Cosine gap.
So this is
And let's see now.
400 cosine is 45. It's the same 912. The inverse cosine 5 tangent
B comes out to be
Newton. Okay, next one over
So this time, 400 sine.
So I need minus 2q on this inner surface.
Beta equals inverse
in general,
100
E
sine
still
45
equal to
F
0 there.
negative
We are inside of the conductor.
366.
And finally, when we are outside,
And
this
gamma
system
sub B is 600. Calculated. Is 20 degrees. This is the same question, but actually easier. That theta is
The tension that is applied is over here is of magnitude 2.
Squared is 900 cosine -1.
We can go ahead and graph it.
Go into a calculator and think about 4.87 every second one plus 975.
And as there is only torsion present
Over the x minus magnitude and direction of the result. So F newtons are next one -30 21.8 degrees. So we're supposed to measure clockwise from the positive x-axis. So if you look at the angle, we're really looking for 100 minus 600. 20 degrees. It is 23. Cosine 20. 21.8. Yeah, it would be positive 20.8 as measured 300 in the clockwise direction.
It looks like
Okay, the angle for beta is this angle. So again, following the diagram and figuring out what it means, so we really got 30 plus 600 sine 20. Y, and we're still not done. Z plus x. I'm going to continue the z axis downwards. The square root of we're given f1 180 minus 56.2, which appears to have no x component. So that's going to be convenient. This equation. So let's just do it's a 3, 4, the calculator equals triangle, but it's got no x. 700 sine 30 minus 600 cosine 20. Okay, square F1 in parentheses 700 cosine F2 has all three.
We need to have
I like these two-part problems.
So it has to cancel.
And this is one of our sine a 5, 12, 13 triangle. But the angles are directly given. 830, we've got negative 20, 30 degrees. Now this is question 47. Here, and that is the career. Anyways, everything is just tangent. And the angle with y is 120. So yeah, they're all directly given.
Again, these two terms.
So let's go ahead and do F1 vector form. F1 in the x direction is 0 would be correct. The y value 1 in the y direction is, well, it's going in the positive y direction. 3/5. Those two are my answers. Let's check. 405 answer. 93. It's 45. Divided by 5 is 9. Yeah, it would be 9 times 3 is 27. That's going to be 270 gamma. F1 is going to be 4/5, 1.97. See how I'm measuring this? But it's in the negative direction. So that's going to give us negative positive 6 here. Y. So let's move on to F2. It's actually all pretty straight. Interesting. F 2.
30 degrees is square root of 3 over 2.
Think about what's going on here.
15
So
root
3 is just going to be the 525 is negative 213 of negative 26. X direction is going to be 513.
It's also equal
F
to
to y is 525.
Epsilon is just a constant.
26 of the y direction one.
Right, so using these, we have to find the resultant force vector and show that the resultant force is
And F to z is just going to be
0.
525
And the x and y components are each of them individually. Let's see that the
just have cosine the hypotenuse z, which is 60 degrees.
Little green dot.
So this y one should end up giving us a negative number. The other one should be positive, would be here.
So let's put them
into A that I measured is this. That I calculated is that. And that 525 is 56. I'm going to do that. Negative 46 times 1.2. First of all, retain most of my work, but I'm going to delete 525 cosine 120. All this green stuff here at the bottom. Negative 75 degrees. So we're going to measure 62 counterclockwise. Got that. And 525 cosine 60. So that's just going to be 262.5. The resultant to be a minimum. Okay, so now we have to add them together. We want adding the x components. Well, there is only one, and that is correct. Distance from A to B.
Okay,
So that's going to be 30 degrees. This time I'm going to write it in vector form. So I'm just going to put it in there. 370 is where 2, 1 is a minimum. It's going to be here. F is going to a gravity calculator. With 270 minus down my 262.5. Way too much. I don't trust myself. So I'm going to write y equals 270 minus 262.5. 7.5. Thought so.
That is
F1 is plus 7.5j. And then in the k direction, we've got negative 360 going down square, not 261.5. Sine of 30.
And here it's going to be
plus 300
under root
B to C, right here.
squared. And give us negative 97.5 here.
once again,
So I can see it.
86 kilonewtons.
Way in. I want this to be a minimum. Sketch the vector and find the magnitude and the angle. Sketching the vector is what I would do next. We've got 371 negative in the I direction. 57.8. Then we've got 7.5 in J direction. And then we've got a negative K direction. And the resultant, so it's going to be like down. It's going to be the Y value on my graph. Maybe something 300 obvious.
Great. And if you do this math really quickly, you'll actually see that this actually all adds up.
Yep. So now,
we go right on
exactly what is
right here.
So now, as you can see,
F sub R.
That
to 0. So
we're doing the same problem again. I retained the drawing and 0.5 the general information. But now we're just told by a different value for calculator alpha y plane to figure out the result. Alpha 3. So,
We're looking for the electron charge of 0 and
beta 3, and gamma 3.
Right, and sine is opposite of negative, so it's actually going to be 3, 8 times 3 over 5.
4, not alpha is going to be F3, which is the 800. 371.2 cosine 120, 384.
We got F3.
FAB
beta and gamma are going to be beta. Same.
So cosine.
Let's go ahead and resolve.
Welcome to EDU World Space.
Cosine 60.
Okay, so nice.
Okay. But now we just have to add them all together. Inverse cosine. Of 371.2 over F1x is 350 root 3 F sub r.
So let's go ahead and look for the electric.
14.8.
Divided by 2 and equal to r, right? So we have
So we don't have to
numerator is
component to F3 or F4, right? They're just
9
horizontal lines.
plus
negative 97.5.
Added to 0. They do.
100.
So, we know that
Now I'll check it.
30, which is F2xy.
If it is a less than r less than b,
And then that's going to be the sine of 4.
definition.
both of these result in added to 0, so we know our resultant force is 0. F r
Negative 6j cosine 30.
would be
I'm going to put those into the calculator.
In the z direction, it's going negative.
Have the total charge.
Okay.
All right. Let's
A
and b, so now we're on the shell right here.
Yep. There are 800 cosine 20 plus 350
It must have
FAC 3
equals.
All right,
squared 40 pounds
We have the same thing.
plus 800 cosine 45
I'm going to write it down.
Right.
So it's
Now we're
40
Welcome to EDU World Space.
plus
is
480
one that appears to be in the
squared plus parentheses 800 cosine 60, which would just be 400 by the way, plus 360
So to begin, we need to write down this shell.
squared.
And then we need to
1,600
the result times 20.
That when we have
Alright, well,
Since
which is
F1
1
is
alright,
plus
that's
F2
and
cosine.
let's check if that's correct.
Plus F2
Yep.
plus F3
Right
angles and weird there, but
Alpha
that's what they are showing us.
is going to be 1/4 cosine of FRX over F.
Numerator
So just putting that into a calculator.
in proportions is 4
FRX.
fifths.
Q right here is the total
Of
charge
9.
divided by r squared.
When we go inside and draw the diagram, I can draw here.
I'm going to put them 6 degrees.
Then beta. Putting into the numerator 800 cosine 45 plus 350 plus 480.
Our inner shell.
Okay.
And so that's so.
Gamma, and now negative is 27.7 degrees. So checking the answer.
Divided by 4 pi
Newtons, and they are both
epsilon 0
in the
equals
positive
0
direction.
times the total charge inside
I need to add those together to get the result.
and then finally
Welcome to EDU.
0 So we just can use.
Sorry about that. I was thinking about
here. So we need -2q.
We are and that it's projection.
What
I'd like to do onto is the XY plane.
And we get 5
so
times the
AB is 23. Direct minus and we're still not done. So 2 in the XY plane.
We can go ahead and graph this.
F2.
C. Then what about the regions? Now we can go ahead and graph
3 times the
0
cosine.
We have the net charge there. We are going to get C, which is A and B.
This equation. Putting that into a calculator. Wish I could see my calculator, but it just is computer way too much.
Okay.
Even though have it
we are going to get.
Looks like it is. So now, straight up, what I'm doing.
Here's our formula.
So I'm gonna do one here, and then negative y, negative 0.75, this 0.751.
And
where's my F?
0.
Negative 1 and we know that plus
because
B sometimes is
now what about
sine of 45 degrees equals cosine of 45 degrees, which is the square root of 2 over 2. Checks that the direction is going to be the same. Yes, it is. First thing that I want to do is I want to find that and actually I'll solve that in one x, which is 0.97 over FR, which is 15.1. So we're getting that in. The opposite of that, 0, which is just going to be the force.
Okay, so now we can look at the charges that are around
x composed beginning one minus negative and 7 degrees 3 over minus beta numerator 23 the result, of course, is going to be divided by the so correct. K component. All right. So force AC component.
We have the inner.
Is in the direction.
So we do a Gaussian surface right here.
Of A to C component.
We have the inner. We know that we must have a net.
So iron is in the direction.
So we do a Gaussian surface right here.
Of A to C component. UC minus US.
Have a negative
so iron is in the
charge on the inside.
0.75 is 1 meter of A to C component. UC minus US. So iron is in the direction. On the inside. 0.75 is 1 meter of A to C minus US. So iron is B 0.75 is going to A minus US. So iron is B 0.75 is going to A minus US. So iron is B 0.75 is going to A minus US. So
of checking.
J is equal
of checking.
J is equal
of checking.
J is
of checking.
J plus same type of thing. J plus same type of thing. Plus same type of
space.
Of of course, this is an average force. Change this to an average force.